In this class, I'll introduce you to the world of containers. So before we jump onto the topic for today, I would like to make an announcement that the other day I created a Telegram group for our channel, and I will use this Telegram group to share some important resources, the resources that I come across while reading some content, or while I surf through the Medium blogs or any other resources. So it will be very handy for me to share the resources on the Telegram group instead on the YouTube community post where the information gets ignored, or after some time it is very difficult to scroll back and look into the resources that I shared. So if you haven't subscribed to the Telegram channel, please use the link in the description to join the Telegram channel and use the resources that I'm going to share. Okay, now coming to the topic for today, that is containers. So what we'll do today is we will try to understand the basics or introduction of containers. This is very important because before you jump onto the concepts like creating projects with containers, or how one container interacts with the other container, all of these things, it is very important for you to understand the basics of containers. Afterwards, I'll also try to explain you what is Docker. So even if you are very new to DevOps, you must have at least heard this term called as Docker because it is very popular. So we'll try to understand what is Docker, but not today. We'll not create any projects or we'll not look into the Docker commands. This is just an introduction class. I want everybody to have their basics strong before we jump onto the creating projects and all other things. Then I'll also introduce you to Builder, because in this DevOps course, I'm also going to explain you how to build projects using Builder, because Builder is a tool that you have to watch for. Going ahead, you will see more and more people asking you if you know Builder, and people creating some complex projects with Builder. So it is very important for you to understand Builder as well, because it has a very good integrations with the modern day tools like Scopio and Podman. So okay, not today. We'll not do any projects, but we'll understand the basics of it as well. Now, before we jump onto this, what you need to understand is a virtual machine. So if you haven't watched the day 3 on our complete DevOps or DevOps Zero to Hero course, I'll definitely recommend to watch day 3 before you jump onto today's topic, because before understanding the world of containers, it is very important to understand the world of virtual machines. Because if you consider virtual machines as advancement to physical servers, then containers is an advancement to virtual machines. So definitely you should have understanding of virtual machines. So watch day 3 before you watch this video. But as an overview, like let's say you have a physical server, you purchase this physical server from IBM or HP, or it can even be your laptop, right? Your laptop is also a physical server. So most of the times when you use this physical server, you don't use the resources completely, right? So that was the problem. Even if you're using your laptop, you don't use the complete resources of your laptop. So to avoid this problem, okay, by resources, CPU, RAM, and hardware, all of these things. So if it is one personal laptop, then that is fine. But when you're dealing with the organization, you have thousands of servers and you are paying for all of these resources. So that was one of the major challenge. So to solve this problem, a new concept, or there was an advancement in the technology, and there was the inception of hypervisor. Hypervisor uses a concept called as virtualization. Okay. Now, what is virtualization? As the name suggests, virtualization is basically used to create a lot of virtual machines or virtual servers on top of your physical servers. So virtual server is basically a logical separation, right? A physical server is something that you can see, something that you have bought, but virtual machine is a logical isolation, or it's a virtual isolation where you have operating system for each of these virtual machines. Okay. And on top of this operating system, you would run your applications. So instead of one physical server, instead of running one application, what you are going to do is you are going to run multiple applications, and each of this application is run on a VM which has its own virtual operating system. Or I mean, it has an operating system, but this entire thing together is called as a virtual machine, because it's a virtual isolation that is created by your virtualization platform and hypervisor, right? So because each of these applications have their own operating system, so they are very secure. Even though these applications are running on a same physical server, but they are logically very tightly separated, not tightly coupled, they are tightly separated because of the individual operating system that they have. right? So this is the concept of virtual machine and how you can effectively use your physical server or your resources in the organization. Now this is very good, right? Now why we have to move towards containerization? If virtualization is working very well, why should we move towards containers? So this is a question, and this is how you will understand containers. Okay, so let's again try to understand here that let's say you have a physical server, and on top of this physical server you have installed a hypervisor. Okay, it can be your laptop as well again. So on top of your laptop also you can install a hypervisor and you can create multiple virtual machines. So for the easy understanding, let's say that you bought this physical server of 100 GB RAM and 100 CPU. Okay, now what you have done is you thought that okay, all of this 100 GB and 100 CPU cannot be used by one team or one project or one application. So you will use a hypervisor and you will create, let's say, four virtual machines. Okay, VM1, VM2, VM3, and VM4, on top of which you install operating system for each of this virtual machine. It can be the same thing that you do with EC2 instances, right? What AWS does is they buy physical servers from one of these vendors, or they manufacture their own physical servers. And on top of these physical servers, what they typically do is they install Zen hypervisors, and using this Zen hypervisors, they will ask you to create EC2 instances, right? So whenever you are creating EC2 instance, it's the same process. You are basically using the virtualization platform of AWS and creating the virtual machines or EC2 instances where you use, whenever you are creating, you define that what operating system you want and all of these things. Well, this is very good. And you created, let's say, 25 GB RAM for each of this virtual machine. But of late, your organization realized that you are not using the complete capacity of this virtual machine, right? So you have saved some money from moving to physical servers to virtual machines. But even after moving to virtual machines, you have realized that one of your virtual machine or all of your virtual machines are not using the resources to their fullest capacity. That means virtual machine one has application one, and this application one on its best day, let's say that this application one receives the maximum threshold load, and even after that, it was only using 10 GB RAM and some 6 CPU. That means it is using only less than half, or it is using, like, it is wasting 15 GB RAM and some, 19 CPUs, even when this application is running on the full capacity. Okay, and when it is running on the less capacity, that means it is even using very less resources and it is wasting a lot of resources. Now you can probably say that okay, on full capacity it is using only 10 GB, so let me reduce it. But what happens when it is running on low capacity, or what happens when this application is not at all receiving the load? So in that time you are wasting more than this 15 GB and 19 CPU resources. So this was one of the major drawback of virtual machine. You can see the same scenario on your EC2 instances as well, right? So what happens is, as a DevOps engineer, you might have created many EC2 instances. You might be playing with Jenkins. You might be even the viewers of our channel. All these 22 days, we have created a lot of examples and everything we tried on EC2 instance. But was there a case? Okay, so this is a question that I'm asking you. Was there a case when you have seen that your EC2 instance was running out of memory? How many times? So if it is running out of memory, how many times did you see this error? Very, very less, right? So you must have seen, I think most of the people must have not seen this error, that your EC2 instance is running out of resources. Even if it is running out of resources, you must have seen it very less number of times. That means most of the times you are using this EC2 instance with not, I mean, with very, very less resources, and you are wasting a lot of resources. This is a free instance, so you don't have a problem. But what if an organization that is using some 1 million EC2 instances? Okay, so let's say an organization is using 1 million EC2 instances, and they are seeing that all of these 1 million instances, or most of the 1 million instances, are wasting resources. So it is heavy loss for the organization. So to solve this problem, containers, or the inception of containers, taken place, right? So containers will solve the same problem. That is, they will effectively use your virtual machines to even reduce this problem. So the problem with physical servers was solved to some extent using virtual machines. Now to the problem of virtual machines is also solved to some extent with containers. Why I said to some extent? Because containers still have some drawbacks. uh, uh, you can use some advanced security policies, or you can do some more things, but even today virtual machines are very very secure when compared to containers, because I'll tell you the reason, but just to tell in one single line, virtual machines have a full operating system. So that means they have complete isolation. Whereas with containers, you will see that containers do not have a complete operating system and they do not run their full operating system. So that means there is a logical isolation, but the logical isolation is not complete. There is one or other way where you can talk from one container to another container, or each of these container talk to the host operating system to share some resources. So there are some drawbacks. So what we can say is virtual machines have solved some problems with physical servers, and containers have solved some problems with virtual machines. Okay, now let's deep dive and see what is the architecture of containers. Because I've told you that, okay, containers have solved some problems with virtual machines and all of these things. Let us see the architecture to understand it even in a better way, right? So containers can be created in two ways. One is you can create containers on top of virtual machines, and the other is you can create containers on top of physical servers as well. Okay, so let's say this is model one, where what a DevOps engineer will do is he will use the IBM or HP servers in his data center, in his organization data centers. What he'll do, he's install a operating system. On top of the operating system, he'll install Docker or any other containerization platform. To create containers, you will need a containerization platform. Just like to create virtual machines, you need a hypervisor or a virtualization platform. So you created a Docker platform or a containerization platform, and on top of this, you have created multiple containers. Okay. So this is one way of creating containers. And the other way is you can basically create a EC2 instance or a virtual machine, anything on top of a physical server. Okay, let's say this is a physical server. It can be your Amazon or cloud provider physical servers, or it can be physical server on your organization as well. Okay, so on top of this, you have created a virtual machine. On top of virtual machine, you can create Docker. Okay, so here you are directly creating on the physical servers, and here you are creating on top of the virtual machines. So Docker or containerization platforms do not really care if they are doing the containerization on top of physical servers or on top of virtual machines. And you will see more and more organization using the model 2. Why? Because when you are maintaining your own physical servers, there is a lot of maintenance overhead, right? So there has to be a dedicated team who maintains these physical servers. Whenever there are new patches, whenever there are new security fixes, or whatever is the case, you have to maintain your data center, right? So you need system administrators. Whereas if you are moving to AWS or any other cloud provider, or you're creating virtual machines on top of any physical servers, so your maintenance overhead is less unless you own that physical servers. So that's why these days you will see more and more of model 2. Initially people were using model 1 as well, but now the usage pattern has changed or shifted a lot to model 2, because these days everybody is on cloud provider, and these days people are looking to reduce the maintenance overhead. Organizations are not willing to maintain their own data centers. So to solve all of these problems, they are using model 2. So in model 2, you will have a physical server, but if you are using a cloud provider, you will not see this physical server. You will directly start from this step where you will create a EC2 instance, or where you will create a virtual machine on Azure platform. On top of it, you will create a containerization platform like Docker or any other containerization platform. And on top of it, you will start creating containers. Okay, so you might say that, okay, both of the diagrams looks very similar. What is the difference? Like I told you, the major difference is that containers are very lightweight in nature. Okay, why are they lightweight? First of all, let's try to understand that. Then let's move to the next thing. So the Docker containers, basically, as I told you, they do not have, okay, they do not have a complete operating system. If this is C1, C2, C3, C4, C5, so the Docker containers, on a contrary, virtual machines, if we see the previous example, a virtual machine has a complete operating system and they have a complete isolation and security. Whereas containers, what they do is they use the resources from the base operating system, or they use the resources from the virtual machine or physical server that they are running on. For example, if the virtual machine is using a Linux platform, and your container requires any dependencies, or it requires any uh, any shared libraries or any of the things from the host operating system or the host virtual machine, they will share the resources. So all of them will try to use from the host operating system. So this is one of the major thing. So saying that, do I mean to say containers do not have operating system at all? No, they will have a minimal operating system, or they will have a base image. Okay, so a container is nothing but, a container is a package, or it's a bundle which is a combination of your application plus your application libraries, that means your application dependencies, plus system dependencies. Okay, your application might require some system dependencies. Let's say your application might require Python, or your application might require any system dependencies. So what your Docker container does is, it will be a package of your application libraries and system dependencies, any other system related packages or any other shared libraries. Okay, let's say your etc or your any other shared libraries will be used from the host operating system. So that's why Docker containers are very lightweight in nature. So for example, you have a virtual machine. Okay, to take a backup of your virtual machine or to create an image of your virtual machine, what you will do is, for your virtual machine you will create a snapshot, right? So usually the snapshots are 2 GB, 3 GB, 1 GB, right? This will be the size of your snapshots. I'm taking a basic example. Okay, even if you consider a very minimal, so your snapshots might go to 1 GB with your application installed, all the dependencies installed and everything. Whereas with container, if you, it depends on the type of container again, but with container you might see this falling into MBs, like it can be 100 MB. Okay, if your application has a lot of dependencies, it might go up like 500 MB, or it depends on how you are using the base image. Are you using multi-stage Docker and all of the things? I'm not going into the details, but you need to understand that there is a significant drop in the size of your image. So because the size of the image or the containers are lightweight in nature, what happens is they are even easy to ship. What do I mean by ship? To move from one place to another. Let's say you want to deploy this Docker container onto a container platform, or you want to deploy this Docker image onto Kubernetes or anything. They're very easy to ship and they're very easy to transfer. Okay, so this is one more advantage. What I'm trying to convey here is Docker containers are very lightweight in nature. And if somebody asks you why are they lightweight in nature, because they do not have a complete operating system. Okay, you can say that Docker containers or containers do not have a full operating system, and they use the resources from the base operating system or the operating system on which they are running on. But your container, like let's say you have a virtual machine, and on top of this virtual machine you want to run some 10 containers, and one container requires Python, second container requires Node.js, third container requires Java. Let's say they are in different forms. So what you will do is, like I told you, in your Docker image you can use a base image, and this base image, like I told you, it can have all of the system dependencies. Okay, so this system dependencies along with your application plus application libraries will form your Docker container, or will form your Docker image. So that's why never say that Docker images or Docker containers do not have an operating system, but they will not have a complete or full operating system. They will have a very minimalistic OS, or they will have a very minimalistic system packages, system dependencies. So this is about your Docker containers or containers in general. So whenever I'm saying Docker containers, always understand that I'm talking about containers and the concept of containerization. The reason why I'm saying Docker containers, so that many people will be able to correlate, because always, most of the times when you are reading about containers, it is like equivalent to reading about Docker containers. Like I told you, in this specific course, we'll also cover Builder, so that you will get to see a different perspective. All the time we talk about Docker, but now you will also see, using this course, the other way of creating images and deploying the containers. I hope the concept of containers is clear till now. Now, what what happens is, why Docker is very popular. So Docker was a containerization platform, and Docker helped the community to write the Docker images. Like Docker came up with improving this concept of containerization, and it created a lot of commands, like user interface and user experience with Docker. Using some Docker commands has become very simple. So to create a container, what Docker has done is it said that, okay, you don't have to worry a lot. All that you need to do is you can simply write a Docker file, right? Just like we write Jenkins files, or just like we write any other script files, you can simply write a Docker file and you can submit this to Docker platform, or you can submit this to Docker engine using some Docker command. Okay, I'll explain that commands. Don't worry about it. And this Docker engine will convert this Docker file into an image. Okay, this is a Docker image or a container image. Now, again, using some Docker commands, you can convert this image into container. Okay, so if somebody is asking you what is the life cycle of Docker or what is the life cycle of containers, what you will say is the first stage would be to write. Again, I'm only talking about Docker files for now. Let us ignore about builder for now. So the first stage would be to write a Docker file and to execute this Docker file and create a contain, sorry, and to create an image, and again execute this image and create a container. So if you're using Docker platform, what will happen is there is something called as Docker engine, okay, which will receive all of these inputs. So you want to convert from Docker file to Docker image to Docker container, you can submit your Docker commands to this Docker engine and it will create all of these things. Just for your reference, basically what we'll do is whenever we want to create a convert from Docker file to Docker image, you'll use a command called as Docker build. And again, here to create a container out of image, you will use a command called as Docker run or exec, like just consider Docker run. Okay, so this way you can create Docker file to image and from image to container. This is a life cycle of Docker. So now said a lot of things. Now let us also try to see that, okay, now everything is looking good. What is the reason for new tools and new technologies? Don't worry about this next 5 minutes that I'm talking about. So if the things are going out of your head, or if things are going slightly complicated, don't worry about it right now, because anyways when we do the live projects you will understand more about these details. But because I also want to introduce you Builder. So what is the problem here is that Docker is basically more very much dependent on something called as Docker engine. Okay, and this Docker engine is basically a single point of failure. What is SPOF? It's a single point of failure. Now let's say if a Docker engine is down for some reason, that means to say that all your Docker containers will stop working. This is a terrible way, right? So off late the organizations or off late the Docker community is working on this one. And the major drawback is that till now there is no, I mean, till now you cannot work around with this issue, that if your Docker engine is going down, then all of your containers will not be responding. And your customers, like let's say you are using Docker and your test team or your customers is looking away, but your containers are not working or not responding because your Docker engine is down. So to avoid this single point of failure and to solve various challenges, like what happens is whenever a Docker image is being built from Docker file, it creates a lot of layers. So again, as I told you, don't worry about this particular section right now. If you are not able to understand it, don't worry. While we do a lot of projects on Docker, you will understand. But it creates a lot of layers, and each of this layer again takes a lot of space, or a lot of storage on your disk. So to solve again this problem, instead of creating a lot of layers, you can and to solve the problem of a lot of layers, to solve the problem of single point of failures and other challenges, Builda said that, okay, let me create a tool, and this tool will help you to solve this problem. So Builda will aim to solve the layers problem, SPOF problem, simplicity. It works very well with Scopio and Podman. So that's why you should also learn Builder. So it doesn't take a lot of time. Builder basically works a lot on commands. So you don't have to write something like Docker files. So in Builder, you can basically write a shell script. And in the shell script, you can put all of the Builder commands and it would create a image for you. And this image can be a Docker image or any other OCI compliant image. So Builder also supports Docker images. You can also create Docker images using Builder. right? So this is basically about the introduction to containers. If something is not easy to understand, please let me know. Like I told you, provide me the timestamp and tell me that okay, at this point of time I'm not able to understand something, so that I can create a YouTube shorts video, or I can reply back to you in the comment section saying that okay, this is how it works and all of the things, or I can share some reference material. I hope you enjoy the video. If you like the video, click on the like button. If you have any questions, post that in the comment section. And don't forget to share this with your friends and your colleagues. I'll see you in the next video. Take care, everyone. Bye bye. Hello, everyone. My name is Abhishek and welcome back to my channel. So today is day 24 of our complete DevOps course. And in this class, we'll be talking about Docker Zero to Hero. So first of all, if you haven't watched the previous video, that is day 23, I'll highly recommend you to watch that video because we covered the basics of containers. If somebody wants to understand what is the difference between virtual machine and a container, or if you want to understand the basics of container, the inception of containers, so definitely watch day 23 and only then proceed with day 24. That is today's class. Okay, now coming to the topic for today, we will be talking about what are the terminologies in Docker. Okay, so if you watch this GitHub repository, as I always do, I created a GitHub repository which will give you a clear understanding of the entire things that we are discussing in this video. Okay, so if you want to learn Docker, let's say you haven't followed the video completely, you can also star this repository, fork this repository, and you can do the exact same things that we are talking in the video. Okay, so don't forget to star and fork this repository. Now, going back to talk about the topics that we're going to cover today. First of all, I'll deep dive and explain you why containers are lightweight in nature. So in yesterday's class, I just gave you an overview saying that containers do not have a full operating system. They just have application plus application dependencies plus some required system dependencies to run your application. And remaining everything they use from the kernel or the host operating system, right? Even the diagram that I'm showing you here, which explains the same thing. On to your right side, there is a virtual machine which has a complete guest operating system. So that's why it's very heavy in nature. Whereas to your left side, you have a container that does not have an operating system. They just have some base image, or they just have some base operating system, and rest of the things they use from the host operating system, like the critical things like the kernel and all the important things they use from the host operating system, and very unique things that your container only required to create the isolation, they are present as part of your container or Docker image. Don't worry, I'll explain you this thing in a very detailed way. I've also mentioned the files and folders, exactly what are present inside a container against what are the files and folders that you usually have in a virtual machine and not in the container. Okay, so I have provided the description as well. So you can refer to this GitHub, or you can follow this video to understand why containers are lightweight in nature. Now, the next thing after that is I'll explain you the life cycle of Docker. Okay, because we want to create containers using Docker. So it is very important for you to understand how Docker behaves exactly, or Docker functions exactly. So I'm going to explain you the entire architecture of Docker. What are the different components that are involved in Docker? How do you interact with Docker? All of those things. Then we will get ourselves, acquainted with the process of Docker. This is the architecture of Docker. But as a user, you have to perform certain actions through Docker CLI to actually build the Docker container, right? So the steps are like you have to write a Docker file, then you create a Docker image, and finally you create a Docker container. So we'll also get acquainted to that process. After that, a key thing is you need to understand the terminology. So terminology is nothing but, the proper naming convention that people use in the community. Like let's say people say that Docker daemon. So you need to understand what a Docker daemon is, right? Sorry for that. Let me go back. Yeah. So you need to understand what a Docker daemon is. After that, you need to understand what a Docker image is, what a Docker file is, Docker registry, Docker desktop, and you have other things like Docker images. So we will understand all of these things with respect to naming convention and the terminology. Moving ahead, I'll show you how to install Docker on a virtual machine. Similarly, like our previous videos, I have created an AWS EC2 instance for the purpose of this video. I'll show you how to install Docker on top of that virtual machine or EC2 instance. Then there are some quite common mistakes that people do, like as a beginner when you start with Docker after installation you run into some common mistakes. So I'll show you how to start your Docker demo and grant access for your specific user so that you don't run into those issues. Then I have a folder in this specific repository which has a very basic Docker file, or you can consider it as your first Docker file. I'll show you how to write that specific first Docker file instead of using the same one that I have in my repository. You can also write your own Docker file by slightly modifying it, and then you can create your own Docker image and finally run your first Docker container, right? We will do all of these things in the current video. And after that, I'll also show you how to push this Docker image onto a public registry so that you can share it with external world. And it is important to share it with external world because that is a real-time use case. Like when you create your Docker image for your real-world application as well, you have to share it with your customers. So it doesn't have to be public all the time. A registry can be private or public. So I'll show you how to push this image onto a private or public registry so that any customer or any people from the QE team can access this and verify the Docker container. So this is what we are going to do today, as this is part one of your DevOps Zero to Hero series. And in tomorrow's class, which is part two of this DevOps Zero to Hero, we will learn about the advanced concepts of Docker. Like instead of writing a simple Docker file, I'll show you how to write multi-stage Docker file. I'll show you how to reduce your Docker images size, because Docker images by definition have to be very less in the size. But most of the times, some people keep adding multiple components or multiple unnecessary packages to your Docker image and keep increasing the size of the Docker image. So I'll share you some best practices how to reduce the size. Then we will write more and more Docker files and execute Docker images. And finally, we will also talk about your Docker interview questions and some other things that are related to Docker. So this is going to be in two parts. So today's part, I'm going to start like I always tell you, please like this video. If you have any comments or if you have any feedback, definitely share that in the comment section, and also share this with your friends and colleagues. Okay, so the first and the very important thing, I also covered this in yesterday's video, but I want to deep dive today. Why are containers lightweight in nature? So if you want to explain this in an interview, I have got a very good explanation in the GitHub repository itself. So you can follow this repository as is, you can learn from this repository, and you can explain the same thing to your interviewer as well. But the main and the primary reason is that, like I always tell you, a virtual machine is like whether a EC2 instance that you're creating or a virtual machine that you have created on top of a hypervisor, they have complete operating system, full operating system, or the guest operating system, because of which they are very heavy in nature. Like let's say you create a EC2 instance. Okay, so the EC2 instance that you have created, whether you use it to full extent or whether you don't use it, you still have to pay money for your AWS or your cloud provider. On a contrary, containers are very lightweight in nature. That means to say that on a specific virtual machine itself, you can create multiple containers. And if the containers are not running, they don't use resources from the kernel. What is a kernel? Kernel is part of your host operating system. Let's say you buy a physical infrastructure or you create an EC2 instance on AWS. It basically has an operating system that has a kernel. So kernel is heart of your operating system. Now you install Docker on top of it. And what Docker does is whenever it creates containers, it says that, okay, container, you can use all the required resources from the kernel, but you can only the base image of the container or the container itself can have only minimum system dependencies. Now, why the system dependencies have to be there? Because this container and this container have to be isolated. Like this can be container of project one and this can be container of project two. If all of the things if container one is using all the resources from the kernel and container two is also using all the resources from the kernel, then that means to say that some hacker who is on container A can access the applications, or he can technically get into container B as well. So there has to be a logical isolation, right? Do you get it? So containers, even though like I say that they don't have complete operating system, but they need to have some part of logical isolation. Without that logical isolation, any people who can log into your Kubernetes cluster, any hacker who can get into your Kubernetes cluster or a specific container, he can get into your all the containers that are present on your cluster, which is like a dangerous hack, right? Or you are compromising with the security of your applications. So project A person should have logical isolation with project B, C, D, E, and F. So that can be done by using some system dependencies, and the rest of the things, all of these containers can be all of the containers can share from the kernel or the host operating system. Now, what are these files and folders that containers have inside them, and what are the resources that containers use from the host operating system? So this is an information that it's not that easy to find. So for that reason, what I've done is I have put this information here, so that whenever somebody wants to refer, they can directly refer from this GitHub page. And whenever you are preparing for the interviews, you can say the exact same thing in your interviews. Because many people say that okay, containers do not have operating system, but they don't have quite good understanding of what that sentence means. So that sentence means the same thing that I'm explaining you. That means containers have a base operating system, or they have a minimum system dependencies, and these system dependencies are definitely required to form a logical isolation from one container to another container. If that logical isolation is not there, or if that minimum system dependencies are not there, then however, if you manage to run your application on that specific container, let's say your hacker, or a hacker who is entering into your container, can typically get into all of the containers and compromise the security of your organization. Okay, now, like I told you, what are the files and folders that a container has within it? Like you have a /bin folder that has the container binary execution files. Then you have sbin, which contains system binary execution files. Then you have etc. I think everybody is aware of etc, which contains the configuration files for various system services. Then you have /lib for your library files. You have /usr or /user, which contains user related files, /var for storing your log files and the other things, and /root, which is home directory for the root users. So these basic folders form a logical isolation from one container to another container. That means a container cannot share these files and folders with another container. If a container is sharing these files and folders, that means you are compromising the security of your container, or the other container is compromising the security with yourself. So that's why these files and folders are not used from the kernel, and they are basically part of your container image or your container base image. I hope this is clear now. Now, let us see what are the files and folders that containers use from the host operating system or from the kernel, right? Because these are not the files and folders that can form your complete virtual machine or complete virtual image or your operating system, right? There has to be lot more files. So that other files are, your host file system, the file system. Everybody understands a file system, right? Then your networking stack, then your system calls, namespaces, control groups. These are basically part of your kernel. Okay. So if you watch our video, I think video number 4, where I explained you Linux operating system, what are the different components of Linux operating system, why kernel is very important, what are the different components of kernel, you will definitely understand that these parts are mostly from the kernel, like they are related to kernel, C groups, or your Linux networking namespaces. So these are the things you can use from your host operating system, and a logical isolation can be created by using these files and folders. So I definitely say to read through each and every line of the GitHub page that I have provided. I took a lot of time to write these things so that anybody who is watching this video, they can get benefit during the interviews. So if you even manage to say the exact same thing, or 60 to 70% of these things during your interview, your interviewer will definitely understand that you have a very good understanding of containers. Like the concept of containers itself means a lot, right? If you are going to implement Kubernetes, if you are going to implement your containers on cloud platforms, you need to have a very good understanding of containers. So this is how you get understanding of containers. Perfect. Now, how small is this image, right? So I always tell you that containers are very lightweight, but how much lightweight are they? in general. So for explaining you, I took a very basic example. I took a very popular container image, that is Ubuntu official Docker image. Okay, so this is official Docker image. What does that mean? That this image is provided by Ubuntu itself. This is a container base image. Now again, what is this container Ubuntu container base image? That means this Ubuntu container base image has all of these files and folders. Anybody who is implementing application on this Ubuntu base image, that application will use all of these files and folders from the Ubuntu official Docker image, and rest of the things like the kernel related things, networking stack related things, or the file system related things, it will use from the host operating system or from the kernel. Right? Make sense? Perfect. So now to explain you, this is official Ubuntu Docker image, and this image is just 28.16 MB on Linux AMD 64 platform. Okay, it is just 28.16 MB. If you compare it with a Ubuntu virtual machine image, like it can go up to 2.3 GB. So this is default one. You can definitely reduce the size of virtual image, and even you can reduce the size of this official Docker image. But if you take the basics, so on a basic out of the box, this image is 28.16 MB, and here this one is 2.3 GB. So you can understand the difference, right? It is almost 100 times smaller. So this is the very good advantage of Docker. So instead of running one virtual machine, what you can do is you can run 10 to 20 or 30 to 40 containers on the same virtual machine, right? Depending on how much resources your containers are using from the host operating system. Okay, so there are cases where if your containers are using a lot of resources from your host operating system, or you can predefine your containers with resources, like saying that my container has to definitely start with 256 MB. So in such cases, this is not applicable. But by default, the beauty of the containers is if they are not running, then they will allow other containers to use the resources from the kernel or host operating system. So that's why you can run n number of containers depending on how much your containers are using from the operating system. So what is blocking the same thing on virtual machines? Because your virtual machines have individual guest operating system. So this kernel, all the resources that are used by the kernel will not allow other virtual machine to use resources from, like, application B in virtual machine B or virtual machine 2 cannot use the kernel related resources from virtual machine A. Okay, I think I explained this a lot of time. So if you still have any questions, definitely please provide me the timestamp saying that I did not understand at this point of time, and I'll definitely make a YouTube short video or any other video to explain you this even in further detail. But as I'm telling you, follow through this GitHub document. Read entirely the README file. You will definitely understand the concept of containers much, much better. Perfect. Now, moving ahead to the topic of Docker. Like I explained you everything about containers now. Now, if you move to Docker, what is Docker? Till yesterday, we were only talking about containers. Like I told you, Docker is just a platform. So what is this platform exactly? So a platform, you can simply understand, like, if you consider Docker as a technology, or if you consider Docker as a, concept, then Docker is a platform that implements this concept, right? Isn't very simple to understand? So if containerization is a concept, then Docker is a platform that implements this containerization. Okay, so that is a very simple definition of Docker. But if you want a textbook definition, you can again take it from here. Docker is a containerization platform that provides easy way to containerize your application, which means using Docker, you can build images, you can run, okay, blah, 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 blah. So even I have written this one. If you want to read through this definition, you can use this definition. But if you want to understand in very simple words, you can simply say that containerization is a concept and Docker implements containerization. So are there any other platforms that can implement this containerization? Definitely. So Podman is a very good competitor. So if you have heard this term called as Podman, or if you have at least heard this term called Podman, so basically it's a competitor you can consider as, and it addresses few complicated problems of Docker. Like Docker is a centralized platform where it has only one Docker daemon, but do not go to Podman directly. So first of all, learn with Docker, because Docker is very easy to start with and understand the concept. Like even if you're running with some issues, you can easily figure out the problem that you're running into. You can easily find out the solution. So Definitely start with Docker, and if you get very comfortable with Docker, you can move to concepts like Builda, Podman, Scopio. But those are the next level tools where you can go to them, but get expertise with your Docker. Now, what is the architecture of Docker, right? So I explained you that Docker is a platform. Now, what is this platform? How this platform will let you create containers, or how this platform will let you push the container Docker images to a private or public registry. So it basically happens through your Docker client. So I'll show you how to install Docker, how to run the Docker commands and all of those things. Don't worry about it at all. But first of all, here, try to understand the architecture. Basically, as a client, or as using the Docker client, the CLI, what you can do is you can execute some commands which is received by the Docker daemon. What is Docker daemon? Docker daemon is a process that you are going to install. When I say you install Docker, that means you are actually installing the Docker daemon. Okay, I mean the heart of Docker is Docker daemon. So whenever you are running some Docker CLI commands, so these CLI commands are received by your Docker daemon and they are executed. So when they execute, they create Docker images, they create Docker containers, and finally, using this Docker daemon itself, you can push your Docker images to your Docker registry. So what is heart of Docker? Docker daemon is the heart of Docker. If Docker daemon goes down, that means technically your Docker will stop functioning, or your containers will stop working, because these containers are, they are running against this Docker daemon, and Docker daemon is the one that is listening to your containers. Okay, so this is the architecture. No, don't worry about this Docker commands, what these Docker commands are doing and all of these things. The primary purpose of showing you this picture is you understand the architecture where there is a client that is Docker CLI. So as a user, you use this Docker CLI to execute some Docker commands which are received by the Docker daemon, and Docker daemon ensures to create your requirement. Okay, if you are asking Docker build, then Docker daemon will build a Docker image for you. If you use the Docker client to execute a command called as Docker run, then it will create a container for you. If you are using the Docker client to execute a command called Docker pull, then Docker daemon will receive this command and it will basically pull the containers from your registry. It can be private or it can public. Now, how does Docker daemon understand what is your registry, like where are these images stored, or where I have to push this? Firstly, you have to create an account with Docker Hub and you have to log into it. So let's not go till there. I'll explain you those steps. But for now, I hope you understood the architecture of Docker. So once you understand the architecture of Docker, you need to understand the life cycle of Docker. Okay. So because the concept of containers itself is complicated. After you understand the concept of container, the rest of the things is only using the Docker platform to create those things, right? If you understand the concept, if you understand how containers work and all those things, Docker is just a platform. And what does this platform do? This platform will allow you to create your Docker images, or your containers and all of these things. So you can consider it just as a CLI tool, or you can consider it just as a daemon service that is receiving your request. So what is the life cycle of this daemon service? First of all, you as a user have to write a Docker file. What is a Docker file? So Docker file is basically a set of instructions. So set of instructions is like you tell Docker daemon that, okay, get me a base image. Like in the previous example, I showed you Ubuntu base image, right? So get me a Ubuntu base image. And inside that Ubuntu base image, okay, so this is my source code. Put my source code into your Docker image. And once you put the source code, run the specific commands. If it is a Node.js, run npm commands. If it is Python, run pip commands, so that all the application libraries and dependencies get installed inside this Docker image. Finally, you say execute this, run a local server, or run a specific set of commands so that the application gets started. So this is the set of instructions you write in Docker file. Now, using the Docker CLI, you submit this Docker file to Docker daemon using the Docker build command, and it creates a Docker image for you. Once the Docker image is created, what is an image? Image is just like, if you compare it with a virtual machine, so image is just like a snapshot. So this Docker image can be executed, or this Docker image can be run. Once this Docker image is run using the Docker run command, what happens is this receives the Docker run command, and it again creates a Docker container for you, right? So this Docker container is your final output, which has Like I always tell you, system dependencies, application libraries, and your application itself. So you can share this with Docker, this Docker container to anybody in the world using a public registry, and they can simply download this container and they can run your application anywhere. Like they can run your application irrespective of downloading even a single dependency, because your Docker container or your Docker image has already all of those things, right? They can simply download your Docker image, they can execute the Docker image, create a Docker container, and they can run it on any platform. So this is the beauty of it. So if you want to like, let's say you want to do these steps manually, what you will do, you will download the application, you will create an EC2 instance. On this EC2 instance you will run the application. Once you run the application, then what you will do is you will export the port, expose the port, you will do a lot of things, right, to run your application finally on a virtual machine or EC2 instance. So this problem is solved by Docker. Okay, apart from Docker containers being light in weight and all of the things, the other important thing Docker solves is the complexity. So it reduces your workflow a lot. Instead of user doing 100 manual actions, one person writes a Docker file. Okay, it can contain an application, it can contain your testing platform, it can contain anything. So anybody who executes this Docker image, everything is created out of the box. That means your Docker container is also helping you in efficiency. Perfect. So once you create this Docker container, let's say your Docker container is also created. Now you shared it with somebody and they have executed it. So that will be your end of Docker lifecycle. Unless you want to tear down this container, you want to do something else with this container. This is a basic workflow of your Docker service. After that, let me explain you what is the terminology of Docker. Okay, so people use many technical terms, right? So when you're working in an organization or when you're working in the open source, you also have to understand these terms and terminology. Without that, it is very difficult to catch what the other person is saying. So Docker daemon. What is a daemon? Daemon in Linux itself is like a service. Okay, so in Docker, Docker daemon or Docker D is basically something that listens to your Docker requests. Okay, so somebody using CLI sends you a request. So this Docker daemon is listening to that API request and it acts upon your request. So it's like a heart of your Docker. Then Docker client. I already explained you what Docker client is. So Docker desktop, ignore it for like 10-15 minutes, where after that you'll understand what Docker desktop is also. Docker registries. So this is very important. Now, what is a Docker registry? So registry is nothing but it's a place where you store your Docker images. Okay, so you share your Docker images with other persons in your organization or other persons in the world, right? So how do you share these things? So there has to be a centralized place. So that centralized place is nothing but, like, this is one of the popular Docker registries, that is Docker Hub. Okay, now what is Docker Hub? Docker Hub is a place where you share your Docker images with external world, or you can also use, any private registry. So similar to Docker Hub, you can create your own private registry, and you can also create private repositories inside this Docker Hub, and you can share with only set of people. Okay, but if we don't go to that details now, you can consider Docker Hub is as a registry. You can create your own registries as well, where you share your images with other people. For example, we are using, I showed you that we want to use Ubuntu, right? So what Ubuntu has done is, this is official Docker Ubuntu image. So Ubuntu as an organization, what they have done is they have created a Docker image. Okay, so this is the Docker image that they have created. And they said that, okay, anybody in the world who wants to use a Docker container image instead of using Ubuntu virtual image, they can simply download this one and they can start using it. Or they can use this one in their Docker file. And on top of this base image, they can add their application and they can run their Docker container. Okay, so your responsibility is firstly to create an account in Docker Hub. Okay, so don't get confused here. Docker Hub is one public registry. There can be any public registry that your organization is using. Okay, so this is a very popular one. So your organization might also use something like Quay.io. Okay, so Quay.io is another public registry. Okay, but even if it is a public registry, just like GitHub, in GitHub also you can create private repositories, right? So similarly, here also you can create some private registries and you can share only with certain set of people. So one common question is, what is the difference between GitHub and Docker Hub? Okay, so people like in an interview, somebody can ask you what is the difference between GitHub and Docker Hub. So GitHub is basically used to store your source code. Okay, so it's a version control system platform of our source code, whereas Docker Hub is again a version control platform for your Docker images. So here not you are not storing your source code, but here you are storing your Docker images. Sorry for that. Here you are storing your Docker images. Okay, so what you have to do first is you have to sign in. If you have an account, you can sign in. Let's say you don't have an account, you can click on sign up and you can create your first Docker account. So it's very basic steps. Just provide your username, email, password, and you can create an account with it. I already have an account, so I'm not creating here, but you shouldn't get any error here. Okay, so don't worry about it. Just provide all of these details and you will create your Docker login. Why you need to create a Docker login? Because in this video, in the future, like in next 15 minutes or in next 10 minutes, when we run our first Docker image, what we are going to do is we are going to share this Docker image with our friends, or we are going to share this Docker image with other persons in the world. Perfect. So this is about Docker registries. Okay. So if somebody asks you what is a registry, you can say that in container terminology, registry is a platform which you use to share your Docker images. And a registry can be a private registry, public registry, and even inside your private registry, you can create public registry, you can create private repositories, just like GitHub, right? But the only difference is this is a image sharing platform, whereas GitHub is a source code sharing platform. Then Docker file, I already explained you. A Docker file is basically a file where you write set of instructions that you are sharing with the Docker daemon. Then images. Okay, images you already understood. Now let us proceed and let us install Docker. But before that, I'm going to show you what is the example that I'm going to show you today. Okay, so I am going to start with a very basic example that is, if you go to the examples folder, you have something called as app.py. Now, what does this app.py has? It's just a very simple Python program, which when executed says hi or hello world. Okay. Now, if somebody wants to run this Python application on a virtual machine or on a EC2 instance, what will be the steps? So the first thing that they have to do is they have to create a EC2 instance. Okay. Even if they want to run this on their laptop, what they have to do is firstly they have to install Python. Right after installing the Python, what they have to do, they have to install the pip, they have to install all the I mean, this is just a hello world, but if it has other requirements, they have to install all the required dependencies on an EC2 instance. Firstly, they have to create an EC2 instance. They have to select a virtual machine image for that. After that, they have to install Python 3. Then they have to install pip dependencies. Then they have to ensure that, the Python 3 working or not. In some platforms, they might have some issue with Python 3. Now you will see what is the advantage of Docker. So if you are using Docker, let's say you want to share this application with the QE team or your testing team. They don't have to do all of these things. They can just download your Docker image, they can run the Docker run command, and they can test the application. Okay, so let us start with installing the Docker. So for our convenience, what I've done is I've already created a EC2 instance. So this is the EC2 instance called Docker demo. And there is no special thing about this EC2 instance. I've not done anything on it till now. I just installed the EC2 instance that is with Ubuntu platform, because throughout our videos we are just using Ubuntu. So I thought I'll just continue with that. Okay, but you can install anything as well. Now let me take my terminal and let us start with the installation of Docker. Okay, so what I'll do here is let me create a folder called Docker. Okay, I'll firstly log into the EC2 instance itself. Okay, so I'm using the SSH command. I'm using my public key, PEM file in general, and I'm logging into my EC2 instance. So everybody knows this step, how to create an EC2 instance and how to log in. If you don't know, you can watch our previous videos, how to create EC2 instance on AWS. Let me clear the screen, right? So now we are logged into our EC2 instance. Now what I'll do is firstly, you can follow the GitHub as it is as well. Like, you can follow the same thing that is present in the GitHub. If you go here, I explained you how to install Docker. Just search for install Docker. You have the same steps, but anyways, I'm going to explain it on my own. So firstly, sudo is because you need access. Firstly, I'll update this repository using sudo apt update. Okay, so this might depend upon your usage. If you are already using your EC2 instance, it will take less time. If it is first time, it will take slightly more time. Okay, so what I'm doing now is I'm just updating my repositories. My apt repositories or apt repos are updated. After that, I'll use a command called sudo apt install docker.io minus y. Minus y is just to say that, okay, I agree with it. Else Ubuntu will ask you, do you want to proceed or not? So I'm installing Docker now. See, it is very easy installation. All that I'm doing is I'm just using the sudo command. So what we are doing here, we are downloading the Docker, we are installing the Docker using the apt repositories. If you want to do it on your laptop, let's say you don't want to do it on an EC2 instance and you want to try it on your personal laptop, then the good thing or the best thing is you use Docker desktop. Okay, so if you search for Docker desktop, so what is Docker desktop? So basically many people might be using Windows laptop or they might be using Mac laptop. So instead of creating a EC2 instance or a virtual machine, and on top of the virtual machine, instead of running the Docker, what you can do is you can directly download this Docker desktop. So again, it will do the same thing. It will basically create a virtual machine, and on top of the virtual machine, it will do all of these things. But it will be unnoticed. You don't have to do a lot of things. Okay, so that's why if you are trying to do everything on your personal laptop, you can use Docker desktop. The link is very simple. Just search for Docker desktop, and you will find this option to install on Apple, Windows, and Linux. But if you are on EC2 instance, you don't even have to do all of those things. You can simply follow the guide and like I showed you, I installed Docker, right? Sudo apt docker install docker.io minus y. Okay, if you go to the history and see, this is the command. Okay, so I installed Docker now. Let me see if Docker is running or not. Okay, to verify if Docker is running or not, what you can do is sudo systemctl status Docker. Okay, and it says that Docker is active. That means the Docker is running, right? So let us try to see. Since Docker is running, I want to verify if Docker is ready to use or not. Okay, so the very simple command that I can use is Docker run hello. Uh, what happened? Yeah, hello world. If I do it, you will see this error. Okay, so very first time, don't get confused with it. You will think that, okay, Docker is already installed, but why I'm getting permission denied? This is because you have installed Docker using sudo, right? And by default, Docker has to be installed using root user only. And Docker daemon, the one that I'm saying, it also executes using the root user. That is one more drawback of Docker. Okay, like I told you, there are a couple of drawbacks with Docker. One is the Docker daemon itself runs with the root user, and the other thing it's a single process. It's a monolithic process. So even if you don't have, I mean, if somebody gets to your Docker daemon, since Docker daemon runs using a root user, they can hack your entire system. And the other problem is that since your Docker requires permissions as a root user, then that can also be a compromise, right? So these are some of the issues, and it's a single process. So even if the Docker daemon goes down, then all your containers are affected. Mhm. So what you need to do is, because Docker is running as root, by default your user, in my case the Ubuntu user, will not have access to it. So what I need to do is I need to use this command called as sudo user mod. So what I'm doing is I'm adding the Ubuntu user, okay, to Docker group. So what this command does is it will add Ubuntu user. This is the Ubuntu user to Docker group. Okay, so that is what the user mod command is doing. It is modifying the behavior of the Ubuntu user and it is making it part of the Docker group. As you do it, now even after this, you will see the same error because you need to restart, or you need to just log out and again log in back. I hope the image is right one. I mean, I hope the IP address is the right one. Let's see. So now if I do Docker run hello hyphen world, see, now you are able to run. That means don't forget to log in back. That means you have to log out and log in back. This is required because you have a user profile for your user. Okay, so this user profile is not by default activated. Either you can source your user profile, okay, using the source command, or else you can simply log out and log in back. So for the people who are not aware of the source command and how to source your user profile, you can simply log out and log in back. Okay, I don't want to complicate it. So for now, just understand that your user profile is not activated as soon as you add your user to any other group. So now Docker is installed and your Docker is up and running. So let us start with writing our first Docker file. What do we have to wait for, right? So let me clone my GitHub repository. So this is the GitHub repository. What I'll do is I'll just copy this URL and I'll say git clone the URL. So you will be able to clone the URL. Okay. So let me go to that specific repository, Docker 0 to hero, ls, and perfect. I have a README file which we were which we were looking into all through this video, and then I have the examples folder. Let me go to the examples folder. So you will see two files here in the example folder, that is app.py and first Docker file. So app.py, like I showed you, it just has a hello world. You can complicate this program as much as you want, right? Because as I told you, Docker will automate the entire thing. Even if you write a complicated Python application or if you write a basic Python application, the steps that end user have to say, or the steps that your customer or your SRE engineer or whoever using this Docker image, they have the same number of steps. That is, they just have to run the container. They don't have to do any additional thing. Now let us try to look at the Docker file to understand how to run this application. Okay, or like I told you, what we will do is, okay, what happened here? Yeah, first Docker file, I need to go to this folder. Okay, now Docker file. Now let me go to this Docker file. If you see this Docker file, what I'm doing is, firstly, I'm saying from Ubuntu latest. That means we have to get a base image for our Docker container. This is very, very important. And that is what I'm stressing from previous class as well. Your Docker container will have a base image. It doesn't mean that your Docker container will run without host operating system. So that's why I'm getting Ubuntu latest from Docker Hub. Why I'm getting from Docker Hub? Because I can get from a public registry. Okay, so I'm getting this information from a public registry. And what I have done is Ubuntu latest. That is, I'm using a Ubuntu image. You can use any image that you want. You can use Debian, you can use Alpine. Okay, and then I'm saying work directory. Work directory is nothing but on the Docker container, you are just using the cd command and you are moving to /app folder. You can ignore this as well for your first Docker file. Then I want to copy the contents here. Okay, so if you see here, what I have is okay, let me move that specific file, copy app.py to here. Okay, so this is my app.py, right? And this is my Docker file. What I'm saying in the Docker file is just copy the content. Okay, just copy the everything that is present in the same folder to /app. Why I'm copying to /app? Because I said my work directory is going to be /app. So all the commands that I'm going to execute inside this Docker image is going to be inside the /app folder. What happens if you don't provide this specific line? Then here you can say simply copy. Okay, so don't worry about this Docker commands. What are these Docker commands? I'll brief you through each and every Docker command in tomorrow's class, but this is our first Docker file. So I used very less Docker commands, and like in this class, you can just understand that, okay, I'm using this Docker commands for running my first Docker image. And in tomorrow's class, Abhishek will explain all the Docker commands and how to use these Docker commands. So I use the work directory for basically forming or for basically telling my Docker image that every action that I perform should be on this specific folder. You can ignore this as well, or you can use this as well. So I'm copying the app.py onto this Docker image, and after that I am installing Python. Okay, why I'm installing Python? Because my application is a Python application and I want to get all of this information into the Docker image so that next time when somebody runs the Docker image, they will also execute the same set of actions. I mean, they don't even execute because the Docker image is already created. They just run the container directly. Okay, provide all the dependencies that are required for your application. And finally, you can ignore this one as well. Finally, just run a command called python3 app.py. Okay, so this CMD is basically used to, it just acts as a command line or, it just acts as an entry point. So it is the first thing that you want to execute inside your Docker container. So python3 app.py. That means I am running this app.py. Okay, so now let us try to execute this one and see what will happen. Okay, so the execution commands and everything also I stored here. So you can directly go here and use the docker build command. Let me show you that. So this is the docker build command. Let me just copy it and use the same command. So let's see what happens. So once you run this command, what happens is, all of the actions that you have provided in the Docker file are executed in a sequential way. So Docker daemon is receiving the instructions in the Docker file using the Docker build command, and it is executing. What was the command that I used? Let us go back and see. So it says Docker build. Okay, so it is asking to build the Docker file. Dot represents that Docker file in the same directory. You don't have to provide all the time -f Docker file. You can simply say dot. So Docker build, and this is the tag that I'm giving. Okay, why I'm providing a tag? Because on your machine or on your laptop or on your EC2 instance, there can be hundreds of images. So if you're not using a tag, what happens is your image will be lost, or your image will be generally created with some commit ID, or sorry, it gets created with a Docker image ID, and that Docker image ID, it is very difficult to remember. So that's why always tag it. And so to tag it, it is very easy. So this is the login information of my Docker. So I created a Docker login, right? So this is the username of my Docker, and this is the repository that I'm going to use, like similar to GitHub. So you use a GitHub user ID, and this is your repository. So when we actually push this image onto a registry, what happens is inside your username, there will be a repository that gets created similar to Ubuntu repository, and this is going to be tag. Like you can say v1, v2, v3, v4. Don't worry, I'll show you. Once we push it, you will understand it in a much better way. Why we use this Docker build command using a tag, you will understand when I actually push it, because you will see in live that, okay, inside my user, inside the Docker registry, inside my user, there is a repository that got created, and the tag that we have given also got created. Okay, so the image build was successful. Now, what I want to do is I want to execute this image and see how my application runs. Okay, so the main purpose of this is to run your application. So what is the command that you will use? Docker run -it, that is an interactive terminal. Okay, followed by the image ID. Just provide this. See, you got the output called hello world. Now this is just a command line application, so that's why you got output as hello world. What if this is a web application? So what happens is your application will start running on this specific machine, and you can access the application from your EC2 instance or from your browser. Okay, so because this is a very first application, I did not want to complicate it. So I want to keep it very simple. That's why we use a hello world application. Whereas if this is an application, let's say this application is a web application, or it's a 3-tier application, then the same things will be executed and you can see the application live on your browser. Okay, so are the things clear till now? Now the next thing is I want to share this application with my friends. So for that, like I told you, what I have to do is I have to log in first. Where I have to log in, I can simply use a command called docker login and use the username and password that you use to create your Docker account on Docker Hub. So username is Abhishek.Veeramalla. So this is a username that I use for my Docker, and password, I remember my password. Just save your password somewhere, or remember your password and execute your password. Your login is successful. Now what you can do is simply use a docker push command, docker push, and say this specific thing, colon latest. That means I'm just using my image. So I'm saying docker push followed by this specific thing. Now let us see what is going to happen. So it is saying it is going to push this image. Let us see where is it pushing and what is going to happen. As soon as this image is pushed, you are going to see that on my Docker Hub. Okay, let me log into Docker Hub meanwhile to show you. So this is Docker Hub. Just let us click on it and let us click on sign in. So I'll use the same user ID and password that I used there. This is my user, and continue on it. Okay, so I use the password as well. Now I logged into my Docker Hub. Okay, I have bunch of images. Don't worry about it. Let us see what is going to happen. So if you see here, my image got pushed. Now what is going to happen? So this is my Docker account, and inside my Docker account, Abhishek FI, my first Docker image got created. If you see here very carefully, it says few seconds ago. So few seconds ago, what happened is there is a new repository that got created that is called my first Docker image, and there is a new tag called latest. Like if you see, the tag is latest, and this is my Docker image. So if anybody in the world want to use this Docker image, they can see here it says public view. This is the Docker command. So they can simply use this Docker command. Okay, so this is for push. You can simply modify it. Let me go to the tag so that you can see that command. Okay, so this is the command. You can just copy this command. Okay, let's say I'll do it on my laptop or somewhere else or for any other person. What they can do is they can simply use this command called docker pull. As soon as they run it, they'll get docker image on their local. They can verify that using docker images command. So using docker images, you see that, okay, in my case, I already have it. But for somebody who do not have it, also using the docker images command, they can see that image is now available on their personal laptop or EC2 instance. So this is how you run your first Docker image and first Docker container. So if you did not understand anything here, just provide me the timestamp and tell me. So one thing is you might not have understood about Docker commands. Don't worry about it. In part 2, that is in tomorrow's class, I'm going to explain you the Docker commands in detail. So if that is your concern, don't worry about it. But everybody follow this GitHub repository. Whoever is watching this repository, watching this video, definitely go through this GitHub repository, try it out by yourself. And there is very, very informative information, not just the things that I mentioned in the video, because I took a lot of time to write this repository and I've shared a lot of useful information. So even this will be very helpful for your interviews. I hope you like this video. If you have any feedback, definitely share that with me in the comment section. Like this video, share this video with your friends. And if you haven't subscribed, please subscribe to our channel. Thank you so much. I'll see you in the next video. Take care, everyone. Bye. Hello, everyone. My name is Abhishek and welcome back to my channel. So today is day 25 of our complete DevOps course. And in this class, we will deploy our first Django web application as a Docker container. Okay, so in the previous classes, that is day 23, what we have done is we try to understand the concept of containers. So if you can go to this repository, you will see all of the things that we discussed in day 23 and day 24. So we try to understand the concept of containers. We'll try to see why containers are lightweight in nature when compared to virtual machines. We try to dig into it and see what are the files and folders that a container has. How are they different from virtual machine? Why a container uses a specific files and folders from the kernel. How is one container isolated from the other container? And then we looked into the architecture of Docker, right? So we understood the architecture of Docker and then we moved to understanding the life cycle of Docker. So the reason why I'm explaining is if somebody hasn't seen the previous videos, then definitely go and watch those videos, because those videos are your stepping stones, or or the things that you have to follow before you jump onto containerizing a web application or containerizing a Django application. So because this application is going to be slightly heavy when compared, or slightly tricky when compared to deploying your first hello world application or just a CLI application. And then we try to understand the terminology. What is a Docker daemon? What is Docker desktop? What is Docker registry? All of these things, right? And finally, we installed this Docker on a EC2 instance, and we also saw what are the permissions issue that a user can get once they install Docker. And finally, we ran a Docker CLI application. Okay, so these are the things that we have done till now. And today's class, as I promise you, I have written a Django application. Okay, so this is a Django application that I have written, and this is a very basic application. Like basic in the sense is there is no difference. Like for example, if you have an idea of how to containerize a web application, then it will not be any different than containerizing a web application that has 3 flows or 2 flows. So this is a single page web application. So even if it is of 2 pages or 3 pages, as a DevOps engineer, you will not worry about it. Okay. So probably if it has 2 pages, then there will be a redirect, or there will be a form action which takes your response. And once a user submits his form action, then it will be taken care by your backend, or it will be taken care by your another view which executes certain actions. And again, you will see one more HTML page, or you render one more template. But this is about the process that developer does in the background. As a DevOps engineer, you should have idea on how to containerize a Django application. So now the common question that people get here is, many people also ask this question in the comment section. So I explained them that I'll make sure to answer your question during this video. And this is the question that, do I need to have programming experience? So to answer this question, you should definitely have idea of programming, not programming. You should have idea of how application functions, okay, or how to basically write a skeleton of an application at least. So in this case, I wrote this entire Django application, but it is not required. Like, I'm not saying that every DevOps engineer should have knowledge of writing a Django application, but at least when you are seeing this application, for example here, you should understand what this application is doing, okay, where this application is getting the requirements from, where this application is talking from one service to the another service, because that is how you will be able to containerize these applications. Without that knowledge, you will not be able to containerize. Like, for example, if you're looking at this application and you are aware of Django, so by looking at it, you will directly say that, okay, so there is one application inside this, or there is only one microservice inside this Django entire project. And here you have defined the configurations for your entire project inside the settings.py. And finally, you wrote the Python code in the views.py, which is executed against the rendering the templates. Okay, so I have rendered the templates using the template folder, and this is the content that is getting served on the URL, or this is the content that is getting served on your browser, right? So this is the understanding that you need to have. Don't worry if you don't have it at this point of time. I'll just take 5 minutes, and I'll try to make sure that people here understand the concept of Django application, because before I containerize the Django application, I just want to make sure that everybody has the knowledge of a workflow of Django application, because tomorrow, if you want to containerize another Django application, the process will not be different. So the number of steps that we are doing, sorry, the skeleton of steps or the flow of the steps that we are doing will definitely be the same. Only thing is, you'll probably install more packages for an application. Probably you might change the entry point, you might change the CMD, but like I tell you, the skeleton or the flow of steps that you are going to do will be the same. So that's why, let me just take 5 minutes here and explain you the flow of Django application. If someone feels that this is not important for them, you can skip this part, but trust me, this is very, very important for you to understand the flow of Java applications, Python applications, Node.js applications. So this is the responsibility of DevOps engineer. If you are a Node.js developer, even if you don't know how does a Python application workflow works, then there is no problem. But as a DevOps engineer, you should definitely have that knowledge. Now, so taking the 5 minutes, firstly, whenever you are writing the Django application, the first thing that you would do is there is something called as like, you can just go to the Django documentation as well. So whenever you are building Django applications, the first thing that you have to do is you have to just start with installing Django. Okay. So once you can install Django, okay, to install Django, what you need to do is you just have to first install Python, and then you can install Django using the pip command. Okay. So Python has something called as pip, right? So using pip also you can install Django, or you can also download it from the internet. Let's say you installed using pip, you can simply use the import Django to verify that your Django is imported or not. Once that is done, this is very basic, right? So I'm not going to deep dive and say how to use pip and all. Many people already know it. So let's not waste time. After you do that, the important thing is to understand that Django has something called as Django admin. Okay. So once you install Django, you can also install this Django admin using pip. Just say pip install Django, and probably the other command that you would install is pip install Django admin, I believe. I don't remember the package name exactly, but I can show you that in the Docker file. So once you have that, so Django admin is very similar to your Ansible Galaxy. What Ansible Galaxy does, if you're following our videos, you should understand that, because we have already seen in the configuration management course that Ansible Galaxy will give you a skeleton of your Ansible role. Similarly, whenever you are trying to build a project, or whenever you are trying to write a microservice with Django, so Django admin can be used to create the skeleton. So here, Django admin start project, and this is the name of the project. But in my case, what I've done is the name of the project that I choose is DevOps. So I use the same command and said Django admin start project DevOps. So that has created a skeleton for me inside DevOps. If you go inside DevOps, so this is the skeleton that it created, except the demo folder. Now, what is inside this three folders? Okay, ignore the demo application for now. I'll tell you what is inside demo. So till now, once you use the start project, it created a project for you. And inside the project, there is nothing related to your applications. So this is only your overall project configuration. Okay. So for example, if you go inside this DevOps, okay, see, these are all your project configuration. So the settings.py has the entire information of, what are the IPs that you can whitelist, what is the database that you're going to connect, if you have any secret keys, if you have any secure information, okay, and probably if you want to use any Django middlewares, or if you want to support any templates, any web server gateway interface, all of these things is present as part of your settings.py. So you can understand settings.py as a settings Python file. Okay, so it will set the entire configurations for your Django application. Sorry, for your Django project, the overall project. Now, after that, you have urls.py, which is responsible to serving the content. So here, if you see, what I said is this is the instance IP address. This is the port. And after that, I said slash demo. Now, what is this slash demo? So slash demo is the context root of your application. So the urls.py will understand that anybody who tries to hit this slash admin, or anybody who tries to hit this slash demo, which I did, it will serve the content on the demo application. Okay. So now what is this demo application? So overall, using the Django project start, Django admin start project, you just created a project. There is no application that you have created. Okay. So you can understand that you have set a base for your application. After that, you have to create your applications. So to create your application, there is again one simple command that is called as Django admin start application. Okay. So this is the command, Python manage.py start app followed by the name of the app that you want to give. Okay. So here in my case, I gave the name of the application as demo. Okay. So if you go back here, so this was the name of the application that I provided. And again, this will create a bunch of files for you. So see how easy is Django, or how easy is it to write a web application or a 3-tier application in Python. Okay. So many people have this worries that, oh, okay, I'm not a developer, I don't know how to write these applications. But as a DevOps engineer, you should also have some basic understanding of development. Only then you can become an extraordinary DevOps engineer. Or if you want to crack DevOps interview positions in good MNCs, or in good companies, then you have to have this understanding. Perfect. So it created all of these files for me, except the templates folder that I'll explain you why I created. But apart from it, it created all of these things. And inside this views.py, okay, so this views.py will already be there. You will write your actual code. Okay, so in my case, I just wrote a very simple Python function, which is called as index. What this is doing is it is rendering a HTML file. Now this HTML file, you have to place in a folder called templates. And from here, your content gets served. Okay, so this is the overall workflow of Django application. Now, if somebody wants to do it personally on their own, okay, let's say you have said that, okay, this is a change that I have to do. I'm done with my change, and let me share with the QA team. So before Docker, or before the existence of containers, the process was they used to download this GitHub repository, or they used to download the artifact that you have created. And then what they used to do is they used to create all the dependencies that you have in this requirements.txt. Here in this case, there is very less requirements, but in some cases, the requirements can go to 100, 150, depending upon your application. They used to install all of them, and then the actual problem starts. So the QA engineer might be on Windows system, the QA engineer might be on Mac OS, he can be or she can be on a specific distribution of Linux where these commands won't work, for example. Okay, so that was one of the classic problems that system engineers, or DevOps engineers used to face. The developer says that application is working fine, but the QA says that no, application is not working fine. So is there a mistake in your CI/CD pipeline, or is there a mistake that DevOps developer is saying, or is it issue with the QA engineer? You will not understand. So this classic problem is again solved by Docker containers itself, because in container, like I told you in the yesterday's class, we are bundling and we are packaging everything for your application to run. So anybody who wants to run this application, in my case, anybody who wants to run this application here, they don't even have to execute one single command other than docker build and docker run. Okay, so those are the only two commands that they have to build. So for that, they just need to have Docker installed on their machine. If they have Docker installed, it is irrelevant to you whether they are using Windows machine, whether they are using Linux, Mac OS, because like I told you in the yesterday's class, again, if we go here, what does a Docker do? So Docker basically runs on a virtual machine or on a bare metal. That means to say on a physical server, and it consumes the resources from the host operating system other than the minimalistic dependencies that it has inside the container. Okay, so it can be Windows or it can be anything, because it has the system dependencies in itself which are required to run your application. So let's say your application requires Python. Let's say your application requires a specific pip module. So everything will be part of your as your container itself, along with the source code or the binary of your container. Sorry, of your application. Only if it requires some information, like it has to consume something from the kernel, if it has to do some system calls. So only that things it will do from the host operating system. Regarding remaining every other thing, it will do from the container itself. So that is one classic problem that the containers is solving. Now let's go and see the roles and responsibility of DevOps engineer here. Okay, so DevOps engineer will get a task called, okay, Abhishek, this is my Django application. Now I want to containerize this Django application. Okay, so you'll get it either as a Jira ticket, or you'll get it as some kind of request to you. Now your responsibility will be to analyze this application. So if you are not good with programming, probably a couple of times you can sit with the developers and you can understand what is the workflow of your application. But as I told you, a good DevOps engineer will already have an idea of how does a Python Django application work, how does a Node.js application work, all of these things. Okay, now as a DevOps engineer, I know that what is the first thing that I have to do to containerize this application. I have to start writing a Docker file, which I have already written and submitted to this specific repository. So anybody who's using this repository, you don't have to worry. Just go to this folder called Python web app, and you can simply execute this Docker build, clone this repository, execute Docker build and Docker run, and you will see this application running on your personal machine. It can be easy to instance or anything. Okay, now as a DevOps engineer, the first step that I would do is I will basically choose a base image. So in this case, I choose a base image called Ubuntu. So if you want to try this same example, you can also try with CentOS and see that there will not be any issue at all. But the only thing is you have to modify these things. Okay, instead of apt-get, you have to use yum for CentOS. Okay, so now from Ubuntu, what I did is I choose a work directory. In the last class, I explained you what is work directory. So it is basically a identification on where your source code is going to save, or let's say you have multiple projects in your organization, or you have multiple people in your team, and whenever you are writing this Docker file, you can create as a standard saying that, okay, we will always put the source code whenever we are containerizing the application in a folder called /app. Okay, so it can be a standard that you can follow. So this is your work directory. After that, this is where your DevOps engineer experience comes into place. That is, like, if you have programming experience, if you are containerizing Python applications, you will definitely know that the first thing to copy inside your work directory is the requirements.txt file. Okay, because requirements.txt is the file where you have your Python dependencies. Okay, so the dependencies that are required to run your application, that is Django and tz data. So what I did is I copied the requirements.txt onto the working directory, and then I copied the source code itself, because you might have the dependencies, but the thing that you need to have is the source code itself. Using the source code and dependency, you will form a bundle, or you will form the binary of your application. After that, what I've done is, okay, I've got the requirements.txt copied. I've got the DevOps source code copied. But if I try to execute this one, now at this point of time, it will fail because this is a Ubuntu base image and there is no Python here. Okay, probably I could have chosen from Python. Then in such cases, you don't even have to install Python. But because we are going in a flow, and in yesterday's class also I explained you using Ubuntu, I thought I'll choose my base image as Ubuntu, and I have installed Python. Okay, so if it is a Python base image, you don't even have to install these things. Once I install Python, so to download the dependencies, I just use pip install -r-r requirements.txt. So every configuration is done now. My application is good to use. And the final command that I have to know as a DevOps engineer is, what should I put in the entry point? What should I put in the CMD? Now, this is again a question that is asked in the comment section, that what is the difference between entry point and CMD? Okay, so I thought I'll cover it in a video, and this is the best time to cover, because in this example, for the same reason, I choose both entry point and CMD. So when somebody asks you what is the difference between entry point and CMD in Docker container, basically both entry point and CMD can be used to execute as your start command, or they can, whenever somebody runs Docker command, Docker run. So both entry point and CMD can serve as your starting command, but the only difference is entry point is something that you cannot change. Okay, so as a user, whenever you are running the container, let's say here if I define Python 3, so they cannot override this value in your Docker image, whereas CMD is something that is configurable. For example, here whenever I'm running the container, I'm saying manage.py run server, and I'm just changing the IP address or port, then that is a configurable field that you have to pass as CMD. Okay, so like I told you, I can also pass Python 3 in this space, same thing only. So I can simply ignore entry point. I'll show you directly. Okay, so here I can also write it in this way. Instead of entry point, I can probably say Python 3. This is also fine, but the problem is I don't want people to change the executable itself. Okay, the only reason why I want my QE team, or why I want my customers or someone to configure this specific thing is probably, let's say, what if somebody has already 8000 port that is used by a different process on their laptop, okay, on their EC2 instance. So they will complain saying that, oh Abhishek, your container is always running on 8000 port, and 8000 port is already occupied on my personal EC2 instance. So I don't have a chance to run this container. So I'll just say that the test has failed, okay, or the application is not working. So for that reasons, what you have to do is you have to have your main executable in the entry point. Okay, so that's the reason. So I don't want them to change Python 3 to Node.js, because this is not a Node.js application. So that's why entry point will have non-overridable values. If it is a HTTP server, for example, you are providing here, so HTTP server, WebLogic or WebSphere or anything, so that will remain the same. The parameters that you are passing to their web server, or the parameters that you are passing for your executable, so here Python 3 will remain the same. And if they want to change anything here, instead of run server, probably they want to integrate with web server gateway interface, they want to pass more values, I'm okay with it. So I can configure, I can put that in a configurable field, that is CMD. Let's say your application, you don't want users to change any of things here. Okay, so in such cases, what you will do is you will pass all of them as part of your entry point. Okay, so if I'm passing everything in entry point, that means if the port 8000 is occupied on their EC2 instance, there is no way your application is going to run unless, like I mean to say, you can pass -f an entry point and all of those things. But on a basic ground, this is the difference between entry point and CMD. That is, whenever you want to pass an executable, so you can use the same approach for your Docker files as well, and this is a very good approach. Okay, so even you should start using this kind of things in your organization if you're not. Okay, so this is how you manage entry point and CMD. So I hope the person who has asked this question is very clear about the concept entry point and CMD. Okay, also we try to cover one more question that was asked in the comment section, that is programming important? So the answer to it is yes, programming is important, and you should have some basic understanding as a DevOps engineer how the application workflow starts. Now let's quickly clone this repository and see what we are going to do, because I want everybody to try this after this class. Okay, so people should start trying these things at their end. Only then you get good knowledge or confidence of your containerization skills. So now what I've done is I've cleaned the container. I've just stopped the container. So even if you go to the browser here, so this is the browser. And if you try to refresh this page, you will see that the application is gone because I have cleaned the container. Now I'll start with the basic. So this is a basic EC2 instance that I have, and what I've done is I just clone this repository. I don't want it to waste the time, so git clone is already done. If you want to clone this repository, you already know where this repository is. You can also find the repository link in the description. So I just entered this repository, and after that, you know that in the examples folder, I place the applications, right? So there are two applications here. One application is first Docker file, which we have already seen in the previous class. It's just a CLI application which says hello world and then executed. But this is the application that we wanted to containerize and we want to execute. So let's go inside this. Okay, so I explained you what is inside Docker file. I explained you what is inside source code. Explained you what is inside requirements.txt. Now, why do you have to delay? Just say Docker build dot. And you see here, the application is built. That means if you do Docker images, you will see that the image is built. So this is the image. Okay. Now what I need to do is Docker. So I'm going to ask you all one question, and let me see what is your understanding, or what are the things that you understood till now. So Docker run. What I'm going to do is I'm going to run a interactive mode. I am saying Docker run minus IT. That is to run this terminal container interactively, followed by enter. Okay. Now, is this application going to run or not? Okay, so if I refresh this application will not run. The reason for it is, okay, I have run this application, but I have not shared the port with my host. Okay, so if you see here, the Django service that is running, or the Django application that is running inside my container, and my container has port 8000 that is exposed. But the main important thing is I am trying to access this application on my EC2 instance and not on my container. So we need to do a port mapping. So there is a slight change that we do to this command, that is Docker run minus p. Let us map the port 8000 on the container to host. Okay, I'm using the same port for mapping. Now, once you run it, you will see that your application will run on your favorite browser. Okay, so this is the Django application that we have containerized and we have executed. Isn't it very easy? So let's say you don't understand programming, or let's say you did not understand the containerization that we have done. Don't worry. Look into this GitHub repository. Everything is documented. Okay, look into the video that I have just done. Let's say you did not understand, watch the video one more time, because that way you get understanding of, or that way you get the confidence that, okay, I can containerize a Django web application. If you can containerize even a single Django web application, that means to say you can containerize any Django web applications, because the process will less or more be the same. Okay. So here or there, you might add a few settings related to your database, or, you might install more packages in your app, but that is not going to change the skeleton of your Docker image. Okay. That is not going to change the skeleton of your Docker file. So that confidence, if you want to get, you can simply clone this repository, try out things, just modify things. Okay, don't worry about it. Just force this repository, keep changing the things. If something goes wrong, definitely put that in the comment section, and we can figure out what mistake that you have done. Okay, so this is about containerizing your first Django application. And one more thing is, I hope you people already know it by now, but the only thing is, you also need to expose this port. Okay, so expose is you have to add this to your inbound traffic rules. So somebody might come up and say that, okay, I've done the exact same things, but still my application is not working. Don't worry about it. Your application is not working because you did not add your inbound traffic rules to your security groups. So just go to the instances, click on the instance, and then you will find something called as security here. Click on the security tabs. This is your security group, which has your inbound traffic rules, and you can update your inbound traffic rules saying that allow port 8000 on this specific machine. Okay, so this is how you do it. So click on edit inbound rules. You'll get an option to add a new inbound rule where you can add all of these things. So choose your type as custom TCP, choose the port that you want, and allow all the IP address. Like the source should be from everywhere. Or you can also choose your laptop depending upon your wish. Okay, so this is how you containerize a Django web application using Python. Now, once you also understood these things, the next topic that you need to understand is the networking in Docker and the commands in Docker. Okay, so I already added these two files into the GitHub repository, but I'll try to cover them as part of tomorrow's topic, because I don't want to complicate this thing, because many people might not have experience in containerizing a Django application. So let us give them some time. Let us give them some time in containerizing both the applications, first Docker file and Python web app. So this is all video for today, and in tomorrow's class we will talk about the Docker commands, we will talk about the Docker networking, and important thing that we will also see is how to reduce the size of your container using multi-stage Docker. Okay, so many people have been asking about multi-stage Docker builds. Please explain how to do it. So I'll also cover that in tomorrow's video. Okay, so I have one question before I close the video, and let me see how many people can answer this question. So this is just a question out of the syllabus. Okay, so today we are talking about Python Django, but I just thought I'll ask this question and let's see how many people can answer this question in the comments box. How many EC2 instance can you run on a free AWS account? Okay, so this is the question. How many EC2 instances can you run on a free AWS account? Can you run one? Can you run two? If you can run two, tell me how you can run. If you can run five, how is it possible? If it is 100, also tell me how is it possible. So this is going to be an important exercise. Like if you want to comment and comment the answer, just do it in the comment section. I hope you like this video. If you like, click on the like button. If you have any questions, share me the feedback in comment section. And finally, don't forget to share this video with your friends and your colleagues. Thank you so much. I'll see you in the next video. Take care, everyone. Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 26 of our complete DevOps course, and this video is going to be a both practical as well as a theory class, and this is very important because I am going to explain you some production issues with Docker, or whenever interviewer asks you what are some of the practical problems that you have faced with Docker or containers and how did you solve them. So many people are asking me this kind of interview based scenario sessions. So that is one of the main reasons I choose to talk about this topic today. So what we are going to learn on a very high level is, one, we are going to understand the concept of multi-stage Docker builds. And the second thing that we are going to cover is distroless images. Okay, so there is a very close relation between both of them. That means by using distroless images, you can improve the efficiency, or you can get maximum benefit of multi-stage Docker builds. Now, many people must have heard about this terminology called multi-stage Docker builds, but you might not have heard about distroless images. So don't worry, we will try to cover both of them practically as well as theoretically. So watch the video till the end so that you get all the useful information. And like always, I put all of this content into the GitHub repository as well. So you can get the details of GitHub repository so that you can try these things practically at your end. Now, firstly, we should understand what is the concept of multi-stage Docker builds. So before that, let's try to see what is a usual process, okay, that we follow to write a, let's take an example, to write a calculator application. Okay, so your task is to uh, like execute a calculator application as a Docker container. Okay, so assume this is a Python application. Now what will be your steps? So the steps would be, to start with, firstly I will use a base image. Let me use Ubuntu in this case. Okay, and after that what I'll do is, if required, I'll set the work directory. If not required, I'll skip it. And after that, I will install the dependencies. Like in this case, firstly, I have to start with installing the Python. So I'll say run apt and install Python. Then I will install probably pip. Then I'll install, let's say if it is slightly advanced calculator and require some Python modules or Python packages. So I'll install one, two, three Python packages that are required. And then finally, what I'll do is, once this binary is built, okay, and I'll try to build this egg file or whatever is PYC file or something, and then I'll execute that. Okay, so as part of the CMD. So this will be a steps on a very high level, right? Slash app, for example. So this will be the steps on a very high level. Now, while this is a very good Docker file that you have written, okay, so there is a problem with this Docker file that you have to understand. Okay, to start with, if you are a beginner, then yes, you have written a very good Docker file. But the problem is that even for this basic calculator application, or it can be a complicated application as well that your organization is using, you only require Python runtime to execute this application, right? Because it's a Python application, you will require a Python runtime to run this application. If it was a Java application, you would only require Java runtime. But if you look at the Docker image that you have created, it has 100 other things. It has a Ubuntu base image. Like this Ubuntu base image will come with a lot of Ubuntu system dependencies, and it will come with apt packages. It will come with apt repositories, right? So it has a lot of overload on your simple Docker image that you want as output. End of the day, you just want to run this calculator application, and that calculator application only requires Python runtime, not even the applications that you have installed as part of these stages. These are only required to build your application, right? So these are two different stages. Build is different, running your application is required. To build your application, let's say you are building a Java application. So to build your Java application, you might want hundred of sorry, Java libraries that you want to put in your pom.xml, or you might require a lot of jar files while building your Java application. But to execute your Java application, what you will require, you only require JRE, Java runtime, plus your Java binary. It can be a jar file, war file, or ER file. So those are the only things that you'll require, right? So why you need a base image, that is a Ubuntu base image that is coming with a lot of overload. But you might say that, oh, okay, I require a Ubuntu base image because I want to install all of these Python dependencies, and it is very easy to install them using Ubuntu. Probably I can also use CentOS or any other thing. So for this problem, to solve this problem, what Docker said is, oh, okay, let me introduce a new concept, and this concept is called as multi-stage builds. Now, what you will do as part of multi-stage builds is you will split your you will split your Docker file, okay, into two parts. Now, this can be multiple parts, but if we go back to our example, I'll start with two parts, then I'll explain you how it can be multiple parts as well. But for first reference, let us start with just two parts. So in the first part, what I'll do is I'll do the same thing from Ubuntu. Okay, then I'll use the run command to install all of the dependency packages, let's say 1, 2, 3, 4, 5. Okay, then what I'll do is I will execute this as CMD. Okay, this was the initial process. But here, what I'll do is in the multi-stage build, I will not have this step. Okay, so instead of executing the command here itself, or instead of executing the entry point here itself, what I will do is I will take the binary from this Docker image or from this Docker file into this specific Docker file. So you can consider it as stage 1 and this as stage 2. So you'll write both the stage 1 and stage 2 as part of the same Docker file. Okay, so this will remain as only one single Docker file. But what you will do is you will have two from statements. So here you will say from Ubuntu, and here basically I will choose a very minimal image. Okay, so it can be an image that has just Python runtime. Okay, or it can be an image that has just Java runtime. Okay, so you'll find these images. I'll show you how to find these images. Or here you can also choose a distroless image. So distroless image, I'll talk in next 2 minutes. But before that, you understand that here you are using a from Ubuntu image because it is very easy to install packages, or it is very easy to get all the dependencies that are required for building your application on the Ubuntu image. For example, Ubuntu image by default has curl. Ubuntu image by default has wget. Ubuntu image by default has a lot of things that are required for building your applications. But these Python runtime or this Java runtime, they are specifically Python images. They might not have curl. Okay, so you don't have to install curl because curl was only required during your build process, because you are executing during your execution stage. You don't require curl because you only have to run. So this specific stage 2 will only have from the Python runtime environment, that is Python runtime base image, plus you will copy the artifact binary from this step to here. What you will do is simply you will use the same copy command, but you will say hyphen hyphen from, and you will say here you will mention enter from Ubuntu as build, for example. You can create an alias from build. Okay, this has again a syntax I'll show you, but here from sorry, copy from your base image, and then you will have the image from stage 1 to stage 2. Here you can simply say cmd /app. So here you will not have entry point or CMD, but in the final stage you will have the entry point or CMD. So what is the advantage with this is you have reduced your image size significantly. All this content will not be in your final image. Okay, so this will be only part of your build image, and this will be your final image. Okay, so if you look at your final image, it will have only Python runtime. It will have only the binary that you have built in your build stage and just the executable. Now, this might look very simple to you, but let's take another example that will clear cut explain you what is the fundamental advantage of multi-stage Docker builds. So let's take a complicated application that has front end, that has back end, and that has some DB related stuff. So in such cases, what you will do is you will effectively choose one base image first, again from Ubuntu, and then you will start installing all of the packages that are required for you. So this is a three-tier architecture application. Okay, so for this three-tier architecture application, front end is React, for example, back end is Java, Spring Boot, and then you have some DB related things, for example, MySQL. Okay, so in this Docker image, you have to install all of these things. Firstly, you will choose Ubuntu base image. Now, why can't you directly choose Java runtime here itself? Anyone can answer this one? You cannot choose Java runtime directly here itself, because if you directly choose Java runtime image as a base image, or OpenJDK as base image, okay, or Python as your base image, the problem would be you have to install hell lot of things. Okay, your Docker image will become very, very complicated. And that was the steps people or DevOps engineer used to do 3 years, 4 years ago. But with the advancement of this multi-stage Docker build, what you are simply doing is base image, you choose a very rich base image. What do I mean by very rich base image? A base image that has all the dependencies. Okay, you are not even worried if this base image is 1 GB or 2 GB. Okay, the reason for that is base image will be removed, and finally the Docker image that you are creating will only have the last stage, that is the final stage. Okay, so to go back to the example, let's say if you are not using this multi-stage Docker build concept, okay, for example, if you are not using this concept, what you have to do is firstly you'll start with from Ubuntu, then you will install all the dependencies regarding Java, you will install all the dependencies regarding React, you will install all the dependencies regarding MySQL, then you will build your Java application, okay, then probably you build your front end, and as part of your entry point, you will execute a combined application, right? So it can be a ER file, for example, /app.ear. So this will be your output that you are execute. The problem here would be this Docker image will go crazy. So it can even go up to 1.5 GB or 1 GB size. Okay, so why did it go to 1 GB? Because you haven't used the concept of multi-stage Docker build, and so it will be in these steps, right? So the first thing, when you download the base image, that is Ubuntu, probably it can be 400 MB. Okay, on top of that you have installed Java, so it can be some 50 MB. On top of it you have installed the React related things, again it can be some 100 MB. On top of it, you install MySQL, then again it can be 100 MB. So you have piled up all of these things on your base image, because of which it went to 1 GB. So using this multi-stage Docker build concept, you can avoid this problem, because in the final stage, what I'll only do is I'll say, because the final image is just a Java runtime environment, I'll say from OpenJDK. Yeah, from OpenJDK colon 11 or 12 or latest, whatever you want to use, the version of the image. So from OpenJDK, just copy the hyphen from the base image. From here we can say Ubuntu as build. Okay, so from Ubuntu as build, you'll create an alias for it. So here you'll say from build, you will copy this specific ER file, and finally as part of the entry point or CMD, what you will do is you will just execute this specific app.ear. So what will be the final image size? If this OpenJDK is 100 MB, and this binary, because this is just a binary, it should not be more than some 50 MB or something. Again, this will depending upon your size, application size, but hardly it will be some 50 MB. So your final image size will only be 150 MB. Okay, so you have reduced from 1 GB to 150 MB. This is the advantage of multi-stage Docker build. Now this can be of multiple steps as well. Okay, so here I just took example of one stage, but you can increase the stages depending upon your application. So in some scenarios, for some people, this Docker multi-stage build, I'll show you practical example as well. Don't worry. But here it can be of 2 to 3 stages. Okay, so in the first stage, you might only focus on building your front end. Second stage, you might only focus on building your backend. And in the final stage, what you will do is you will only get the dependencies from front end stage, back end stage, and as part of your CMD, you will just execute it. Okay. So if somebody asks you what are the number of stages that can be in a multi-stage Docker build, the answer is countless. So you can create n number of stages, but there will be only one final stage, which will be a minimalistic image. Okay, so it has to be a minimalistic image, because by choosing a minimalistic image, you will get the advantage of your Docker multi-stage build. So here I'll introduce you to distroless images. Okay, so now we have set the ground very well for you to understand what is a distroless Docker image. Many people find this very complicated topic. I don't even understand why people find it difficult, because I looked into some Google groups, Google forums, the ones that I've subscribed to, or the CNCF Slack channels. People ask a lot of questions on distroless images, but this concept of distroless images is very, very simple. Okay, so don't get confused. Distroless image is basically a very minimalistic image. Okay, so it is a very minimalistic image that will hardly have any packages. Okay, so for example, like I told you, if you choose a Python distroless image, now where will you get this distroless images? Don't worry, I'll show you that as well. So if you want to choose a Python distroless image, so this Python distroless image will only have Python runtime. Like in the previous example, I explained you, I will choose a OpenJDK distroless image. Like I told you, this will be only 100 MB because it only has OpenJDK. Okay, now there will be another kind of distroless images that will not even have Python runtime. For example, if you take example of a Golang application, Golang application is a statically typed application. Okay, so these statically typed applications, they don't even require runtimes. Okay, so you don't require a Go runtime for executing Go application. Okay, so because of which you will reduce your Docker image to typically, like, some 10 MB or 15 MB size. Okay, and this will be our practical as well. So the practical example that I'm going to show you, that is intentionally on Go language, because I want to show you the advantage of distroless images plus multi-stage Docker build. Okay, so what is a distroless image? A distroless image is a very minimalistic or lightweight Docker image that will have only the runtime environments. Okay, so if you are choosing a distroless image called as Python distroless image, okay, this Python distroless image, even if you try to perform some basic shell commands, like for example, I'm telling you, if you try to use a shell command called find, you'll get error saying that find executable is not found. You will try to use some basic shell command like curl or wget, or even in some cases you will not be able to perform commands like ls, because the main idea is to just have a runtime environment, or just to have your final Docker build that only has a Python runtime, and the only purpose of this environment is to just execute the slash app or Python application. So one biggest advantage that you would get from distroless images is the security. Okay, so other than reducing your container image size, you will have highest security with distroless images. So this is something that you can answer in your interview as well. When someone asks you what is one of the production issue that you faced with Docker containers and how did you solve it, you can say that previously we were using Ubuntu base images, or previously we were using, even in the final stage, we were using Ubuntu images or Python runtime or any other runtime images, which were exposed to some kind of vulnerabilities by hackers, or people usually find some kind of issues with these images. So we moved to distroless images. If you are using a Python application, for example, in your organization, you can say we moved to a Python distroless image which only had Python runtime, and because of which, like, it even did not have some basic packages like find, ls, wget, curl. So it was providing us highest level of security, and we, after implementing distroless images, we are safe to say that our applications are not exposed to any OS or operating system related vulnerabilities. Okay, and let's say you are using applications like Go language, then you have even highest level of advantage using distroless images, because you don't even need a runtime. So this distroless images are like, you can literally say they are 99% of times not exposed to vulnerabilities. Okay, if you are using applications like Go language, if you're using applications like Python, at least they have Python runtime. So there is a very little chance. Okay, little means like, very, very little chance of exposing to security threats. Now, I hope you understood the concept of this distroless images and whatever I was talking. Now, what I will do is I will first show you the example that we are going to discuss today. Okay, so like I always do. So this is my GitHub repository. This is my GitHub organization. Let me increase the font. And I have a repository called Docker 0 to Hero, right? So you can go to this repository, all the Docker classes we are trying to learn using the same repository. And in the future classes also, where I'll talk about networking, I'll talk about volumes, I have already prepared the content and it is ready. So if you go to examples folder here, you have something called as Golang multi-stage Docker build. So why did I choose Golang explicitly? Like I told you, you can understand the biggest advantage of multi-stage Docker builds with programming languages or the applications like Golang, because they are statically typed and they don't even require the Golang runtime. So you can replace the same application, like you can write a Python calculator application and you can try, and even you will find the advantage of distroless images. Don't worry. Oh, sorry, I was not sharing my screen. So let me stop sharing here and show you the screen. Sorry for that. I can stop sharing here. Just give me a moment. Stop share and let me share this one. Where is this? Yep. So share. Yeah. So if I go back, I was just explaining about this repository here. That is Docker 0 to Hero. So you can go to my GitHub organization and you can find this repository called Docker 0 to Hero. And in this repository, I have a folder called example, where I am going to explain or demonstrate the multi-stage Docker build using Golang multi-stage Docker build. Okay, so reason why I choose Golang is I already explained you. I was sharing the wrong window, but I hope you understood the concept that I was explaining. So let me clone this repository. I already cloned this repository, to be honest. And now I will execute this Docker file. I'll show what is this calculator application, and let us see the difference by using multi-stage Docker build and by not using multi-stage Docker build. Okay, so that it will be clearly evident, and you will see a drastic advantage of 100 times less image. Okay, so the size of image that I'm going to show you will go by 100 times by using the concept of multi-stage Docker build. Yeah, so we are all excited. Let us go to examples folder. Let us go to Golang multi-stage Docker build ls, and now this is the calculator application. Oh, sorry. Yeah. So this is the calculator function that I'm going to run. Simply you can do go run calculator.go, and you will see what I'm going to show you. So this is a very basic application which says provide the inputs for the calculation. Like if I say 2 into 2 times of 100, so it will give me 200. Like if I say 5 divided by 2, so it will give me the output. Okay. So this is the calculator function that I'm going to show you. Now we will containerize this, and what we will do is we will execute the container. So let us firstly start with Docker file without multi-stage. Okay, so go to this folder that says Docker file without multi-stage, and it will have something called as a Docker file. So what are the steps? I just have a base image that is from Ubuntu. I call this as build. You can ignore just for keeping in sync with the multi-stage build. I just created an alias, but from Ubuntu, what I did is I installed Go language, and then I enabled this Go modules as off. Don't worry about it. Then I copied the source code, that is calculator.go, into this specific thing. And finally, I'm running the Go build and building the binary, and I'm executing the binary as part of the entry point. Okay. So if you're not familiar with Go language, don't worry, your steps will be replaced here. So if you are a Python application, this copy command will be the same, the calculator.go, or you can also use the Django application that I explained in the previous class. This will be the same. This will be removed. You only have to modify this specific command. Okay, or you can directly put your .py in your entry point itself. But I will recommend you to create a .pyc or a egg file and execute that egg. Now, What I am doing here is I am copying the source code. I am I'm building the Golang binary, and I'm running the Go runtime or the Go binary. But as I told you like 15 minutes back, to actually run this, I don't require the source code. I don't require Go language. I don't even require the binary. Sorry, I require the binary, but I don't require the source code. I don't require the packages that I have installed. So let us see what will be the image size here. Okay, so let me build this one. Let me go to this folder and let me build the calculator application. So go docker build -t. Let us provide a tag and let us call this as uh, simple calculator and dot. Let us see what will be the image size of it. So what it is initially doing, it is pulling the Ubuntu image, then it installs all of the things. It is done. Let us see Docker images. I have a lot of images on this laptop, so just I'll do head -5. So you will see the latest 5 images that are built. So simple calculator. What is the size of it? 861 MB. So do you really think for this basic calculator application, do I need this much size of Docker image? Like you can say that, oh, Abhishek, you can reduce the Docker image size by simply using, like, instead of using Ubuntu, you can probably use something called as a UBI image. Red Hat provides a UBI image, which is lighter, UBI minimal, for example. Okay. So this UBI minimal, you can say that it is lighter than Ubuntu. Why don't you use it? Or you can also say you can simply use Golang, right? Not distroless, but you can directly use a Golang image that Go is providing. You can do all of those things. Even after that, your image will not come less than 500 MB or 400 MB or 300 MB. Now, what I'm going to show you is the concept of multi-stage build and the distroless images, by which you will be shocked to see the size of the final image that I am going to create. Can anybody guess here? Like, it will be great if somebody can give a right guess. What will be like the image that we have built is 861 MB. Now, using the concept of multi-stage Docker builds, what will be the size of image that we are going to create? Any guesses? Let us see if somebody will guess right in the comment section. So what I'm doing here, like I told you, I have split this into two stages. One is the base image stage, and one is here starts the magic of multi-stage build. This is the final stage. Okay, so I have split the Docker file into two stages. This is stage one, and this is stage two. If you clearly see in stage one, I don't have entry point or I don't have CMD, right? So what I've done is stage one is only dedicated to the build steps, where I've used the Ubuntu base image. Then I have used this one here, like I have downloaded the Golang, then I've copied the source code. Finally, I created the binary. And in the final stage, I'm using a special image called Scratch. So this is minimalistic distroless image that we have today. Okay, so there can be any new things that I'm not aware of, but as far as my knowledge is concerned, Scratch is the minimalistic distroless image that we have till date. So that's why, to show you the biggest advantage of distroless images plus multi-stage Docker builds, I've used Scratch. So if you try to use the same thing for your Python application, it will fail, because your Python application requires Python runtime, but Go language applications will not need Go runtime. So if you decide to use Scratch image, then what you need to do additionally is you have to install Python on this Scratch image. So instead of Scratch, if you are using Python or Java applications, you can choose Python or Java distroless images. I'll show you how to find them. Don't worry. So from scratch, if you're using Go language application, use Scratch. From scratch, just copy the binary. So as I told you, this is the syntax from hyphen hyphen from build. That means I'm copying the binary from the build stage that we have created here, and I'm just executing it as part of the entry point. Let us try to execute this and see what will be the size. So Docker build. Now I'll say simple calculator multi-stage. Okay, just for our reference, and dot. Let us see what will be the image size. What happened here? Oh, sorry, I did not provide -t. So the command is wrong. What I missed here is I have to provide -t because we are tagging the image. So now let us see what will be the size. I'm very sure most of you will be shocked to see this. Let us use the same command called docker head -5, and the size has gone down to, do you see it here? Simple calculator multi-stage. What is the size of it? 1.83 MB. Now, can you imagine how many times the size of the application has gone down? So this was the size of simple calculator application that we have created, that is 861 MB. And this is the size of simple calculator multi-stage, that is only 1.83 MB. That means we have reduced it by 800 times, close to. Am I right? So this is the demonstration that I wanted to show you. And it is really important to understand the concept of multi-stage builds. It is really it is really important to understand the concept of distroless images, because that is the future of containers. The main advantages that you have to talk in interviews is by moving towards multi-stage builds and moving towards distroless images. We not only reduce the size of the image, but we also made sure that the container images that we have, or the containers that we have, are running securely and that are very less vulnerable to the threats, right? So this is the advantage, guys. And now let me show you how to find distroless images. So all that you need to do is you just have to search for distroless images. You will see a GitHub repository for distroless images. Just go there, and what you will see is a bunch of folders here. Let's say I want to find for Java. Just go to the Java folder, and in the readme.md you will have the location of this distroless images. So if you want to replace, like the same example, if you are using a Java application, what you will do is you will go to my Docker file, and finally, instead of scratch, what you will do is you will just replace with this distroless images. If you want to use OpenJDK 11, if you want to use OpenJDK 17, you will use this distroless image. And I have also tried that. So because I wanted to show you people in the demo, I also initially played with a Java application, but finally I choose Golang application because it has the biggest advantage. But if you're using a Java application, then again the image size has come down to 200 MB. Here in this case it is slightly more because we have the OpenJDK dependency. But if you are using the Golang application with a very bare minimal scratch, it only has 1.83 MB. So this is the biggest advantage that you are getting with distroless images and multi-stage Docker build. I hope this video was informative, and I hope you learned a lot of things from this video. So if you like this video, click on the like button. If you have any feedback for me, share that in the comment section. And finally, don't forget to subscribe to my channel, Abhishek.Veeramalla. Thank you so much. I'll see you in the next video. Take care, everyone. Bye. Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 28 of our complete DevOps course, and in this class I will talk about Docker networking, right? So this concept can be considered as container networking as well, but the reason why I am focusing on Docker is till now whatever we have learned in the entire container architecture, or the concept of containers, we understood using Docker. And even in the last 4 to 5 classes, we have been completely focusing on Docker. So that's why I want to restrict this as well with respect to containers, so that you can go ahead and practice your containers with Docker, the networking, and all the other projects. So if you haven't watched the previous videos, I would highly recommend you to go back and watch those videos, because we have been following a particular hierarchy which will help you to understand Docker as well as Kubernetes. Going ahead, we will deal with the concepts in Kubernetes as well. Perfect. Now, firstly, let's try to understand why you need networking in Docker and what is Docker networking. So basically, networking allows containers to communicate with each other and the host system. Now, what is this? Okay, so if we take a basic classic container example, what is the usual scenario? You have a host. So the reason I am talking it as a host, it can be EC2 instance, it can be physical server or anything. So I don't want to go into the details. Let me simply call it as host. On top of this host, let's say you have installed Docker. Okay. So typically what happens is you might have installed multiple containers here. So let's call this as container 1 and let's call this as container 2. So this can be your basic development application, and this container can belongs to your finance or payments related things. Okay, there can be a reason one container has to talk to another container, or there can also be a scenario where one container should be completely isolated from another container. Let's understand two scenarios. Okay, scenario one, let's say this is front end container, and this is, instead of finance container, let's call it as back end container. So obviously front-end container has to talk to back-end container. So there has to be a common way how this container talks to another. So that means there has to be a networking way of how one container can talk to the IP address of another container. And if you leave this case, by default, any container should definitely talk to your host, right? Because like I always tell you, the containers are basically a very lightweight packages or bundles which do not have complete operating system. If you are taking example of a virtual machine, what happens with a virtual machine? Each virtual machine has its own operating system, right? So a VM is basically operating system plus your application, operating system plus your application. So each of the applications, like application 1 and application 2, are completely isolated from each other. So they have, like, you can attach one subnet to this and you can attach different subnet to this. So what is a subnet? Subnet is basically your networking group. I mean, I don't want to go into the details of subnet now, but basically, let's say you can say 172.16.1.1 here, 1.2 here, and you can say 172.18.3.4. So this network and this network are completely isolated. So by default, you have that flexibility in your virtual machines. Whereas, like I told you, there are two scenarios with respect to your containers. So the scenario one can be one container should talk to another container because, like, let's say this is a front end container, this is back end container. So obviously they have to talk to each other. So the second scenario is you might want a very good isolation between this both of these containers. Like I told you, you can understand these containers as a payment related container, which has a very secure information about your user details, or it has very secure information like you have stored credit card information or debit card information in the payments related container. Whereas you have another container that is just like a login one. Okay. So anybody who has access to login container should not have access to payment container, right? Because this is a very basic container. Like he can be a development user, he can be admin, he can be tester, he can be anything. But you want a logical isolation between these two containers. So scenario one is both can talk to each other. Scenario two is you want a very good level of isolation. So container networking offers you both of these solutions, and both of them are very, very important. So before I explain you both of them, or before I explain you what are the different types of networkings that are available and what are the different types of networkings that you can create to achieve number one and number two. Okay. So before that, I'll explain you the concept of how a container can talk to your host operating system, or how a container can talk to your host. So let us write point one and point two so that we have a very clear understanding. Point one is container one talks to container two. Step two is container one has isolation with container 2. Now we will also do a very good practical demo at the end of the video so that you understand this entire concept. Okay. Now, how does a container basically talks to your operating system, or how does a container talk to your host? Let's say you have created a container here. Okay. So this is my container. Let's call it C1, which has an application. And this is my host. Anything, host can be anything, right? So EC2 instance or anything. By default, whenever you are creating host, or even if you look at your laptop, there is a network called ETH0. So ETH0 is a special network that is available out of the box. Let's say this network has 192.16.3.4, for example. And here you have a container. Again, ETH0 network is by default created for any resource that you are creating, whether it's a container or a virtual machine or anything. So here, let's say this is 172.17.0.2. Now, you can clearly see that there is a networking, or there is a subnet difference. This is 172.17 and this is 192.16. If you try to ping from this to this, what you will see is you will see a networking error. So container cannot ping to your host. So to solve this problem, what Docker has done is whenever you create a container, so Docker creates a virtual ETH. Okay. So there is a virtual Ethernet, which basically is Docker 0. Okay. So you can also try it on your laptop and see. So without this virtual network, a container cannot talk to your host, right? So by default, whenever you are creating a container, this gets created, right? And this is called as bridge networking. Okay, so what is the default networking in Docker? The default network is a bridge networking. The reason why it is called as bridge is because a container has a different subnet and your host has a different subnet. But how a container can talk to your host by default is using a bridge, and this bridge is a virtual Ethernet, right? So it is called as vEth, which is Docker 0. So if you try to delete this network, or if you try to somehow manipulate this network, a container can never talk to your host. What happens if a container can never talk to a host? That's it. Like if a container, like you all of you already know that a container does not have a complete operating system, or a container requires, like for example, a user is trying to access your application within the container, but the container is sitting with inside your host. If user is only able to access your host and not your container, then your application that is sitting inside your container is not reachable, which is, that means there is no point of you using containers, right? So what happens if there is no bridge networking, or what happens if there is no vEth or Docker 0 network out of the box? Whenever you are creating a container, you would land into a problem because the application that you have installed in the container is not reachable from the internet. If the application is not reachable from internet, then users or your clients cannot access your application. That means your application is not reachable, which is, there is no point of installing your applications inside the containers. So that's why, what is the default network that you have, or what is the out of the box network that you get whenever you install containers, is bridge networking. So by default, the Docker network is bridge network. Now, is this the only network? No. So Docker offers you multiple ways. Like if you go back to the example, this is not the only way. Like the this block that you're seeing here, the virtual Ethernet is not the only way how a container can talk to your host. There are different ways, but I'll tell you like the disadvantages of each of them and the advantage of using bridge network. So the other networking option that you have is host networking. That means the containers will directly use the network of your host. So in this case, what Docker does is, whenever you are creating a container, Docker will directly bind your container with the IP address of your host, not the IP address, but the ETH0 of your host. That means, let's say your host has 192.16.3.4, and you create a container, probably you'd get something like 192.16.3.6. So both of them are in the same CIDR block, or both of them are in the same subnet. So by default, when you try to ping from the container to host, it is possible. So anyone who is trying to access the application inside your container can directly talk to the application, because the host networking and the Docker networking is same. So that means whoever access to your host can directly have access to your container as well. But this is a very problematic approach, because you know you want containers to be very, very secure. One of the primary reasons to go to containers itself is they are very secure in nature. If they are not secure, you have to make them secure, right? So why containers are secure? And we also talked about like you remember, we spoke about distroless images, right? We spoke about all of these things to make your container secure. So if you have a complete operating system, or if you have a complete networking that is common to your host, so you will land into the problems. If you have complete operating system, there can be issues with the packages that your operating system have, which have no reason why your application has to use that packages. So that was one of the problem of using complete operating system. Or if the networking is common, someone who has access to your host, okay, by default, because your container as well as your host share the same network, then again they land into the issue, because the this is one of the most insecure way of creating networking in Docker, that is the host networking. And there are other ways as well, like one of the other option that you can do is overlay networking, but this is somewhat complicated, and we will learn very much about the overlay networking when we move to Kubernetes or Docker Swarm. Okay, so overlay network is very popular when you are dealing with this COE or container orchestration, uh, container orchestration engines, because the overlay networking is very useful when you have multiple hosts. Let's say instead of one single host on which you install Docker, if there are multiple hosts and you want to create a cluster on this multiple hosts, so overlay network will create a network that is common across this multiple hosts. Okay, so I don't want to go into the details of overlay networking and why you should use over. If you are just using Docker and if you want to just run containers on your Docker, then overlay networking is too much. You don't even have to bother about it. So there are other networking as well, but these three are very popular networkings. Now, if you go back to the problem, so I mean, or if you go back to the example that I just explained you, what did I explain is there is this one host, and on top of this one host, if you install container one, which is called container C1, right? This is each zero of container, this is each zero of host, right? So now there is a virtual ETH that is created, which is called Docker 0, using which you are talking to your host, right? So user can access from your host to through this virtual Ethernet to your container. Let's say there is another container, C2. And if we go back to the example, this is login container and this is finance container. In the previous example, it was front end and this was back end. So definitely one container should talk to the another container. But here, one of the container is just a login container and the other is finance container. So this container has to be completely isolated or as much secure as possible from this login container. But if you use the default networking option, what happens is there is only one v8 or there is only one Docker 0. So the finance application will also use the same virtual Ethernet, and using the same virtual Ethernet, it will talk to the host. That means both of them are using the same virtual Ethernet, that is Docker 0 or Docker O. So this is the problem. That means there is a common path for the hacker. Okay, so this is the common path for the hacker, or even if not the hacker, like it can be your internal hacker, or internal any person who wants to mess up with your network. So there is a very common path if you are using the out of the box bridge networking. Okay, so all of the containers, if there are 100 containers, all of these 100 containers can ping, one container can ping to the other container, or one container uh, can talk to the other container using this v8, or one container can talk to the host and the other container can also talk to the host using the same v8, that is Docker 0. So this is the out of the box nature, and this out of the box nature is also not secure. So for some people, this might be okay, right? Because you might say that, oh, okay, I don't have any problem. One container talking to the another container. I don't want any networking isolation between my containers. So this can be step two that I talked about. So there are two cases. One is one container should talk to another container. The case two is one container should not talk to another container. If it is front end and back end containers, they can talk to each other. But if it is login and finance, this application has very secure information like user database, or the employee details, or anything related to finance of your organization, whereas this is a basic login application. So there has to be a logical network isolation. How do you achieve this? Okay, so this can be achieved again by using the bridge networking itself. Okay, so like I told you, there are three networkings: bridge, host, overlay. Using host, you can definitely not do it because all of the containers share the same host network. So that's not possible. Overlay network is again very complicated and you don't want to implement. So how do you achieve this with using bridge network? So what Docker does is it will allow you to create your own custom bridge networks. What do I mean by that? So Abhishek, previously you told that there is only one bridge network that is out of the box. Yes, I am right. So out of the box, whenever you are using Docker, there is only one bridge network. But I did not tell you that you cannot create multiple bridge networks or custom bridge networks. So by default, a container will talk to the host using ETH-O, that is vETH, right? So the ETH-O of here and the ETH-O of here are connected using the Docker O network, which is a virtual Ethernet, right? But what a containers or what Docker offers you here is you can create custom bridge networks. That means instead of you going through the same path, if you go back to the same example here, instead of everything going using the same path, what you can do is you can split your network. Okay, where is that slide? Yeah, this one. So here, what you can do is The each zero, this one here, the container one, that is a login container, because it does not have to be secure. It can use the v8, it can use the docker 0 and directly talk to the host. Whereas I'll create a new custom bridge network for my finance, and using this custom bridge network, which I'll call it, if this is docker 0, I'll call this as custom bridge network, for example. And using this custom bridge network, I can talk to this host. So what happens is this chain that I was talking about is broken, or this common path is broken. Now this will directly talk to the host using docker 0, and this will directly talk to the host using the custom bridge network that I created. So this is how you achieve the logical isolation in Docker using the bridge networking itself. Okay, so if I have to explain you one more time so that the things are very clear to you, this is your host, right? And this is the ETH network. Let's call it 172.16.3.4 of the host, right? And this host has, for example, a virtual, sorry, ETH0. This is the ETH0. Now, I created container 1 and I created container 2. I created container 3. This is just login app. This is just logout. But this is payments and finance related things. So this has to be very secure. So for container 1 and container 2, I will not do anything. I'll just create containers as we learned in the previous classes, right? In the previous classes, I just told you just run docker run command and your container gets started. So I'll use the same method here. And what happens is both of them, they will connect to the virtual ETH. From there, they will connect to the docker 0. I mean, there is again, uh, this is just for your understanding. So there is only one virtual Ethernet network from which it will connect to this host. Whereas payments 3 or the container 3, the finance container, which has to be very, very secure, what I'll do is I'll create a custom bridge network using the docker network command. Okay. And using this, what happens is when I create a new network, for the docker run command, I can simply pass this network as an argument, hyphen hyphen network. Okay, I'll pass this an argument, and what happens is this will connect using this virtual bridge network that you created. Let's call this as virtual bridge. Anything, you can call this as anything, to the host that is ETH0. So container 3 is completely isolated from container 1 and container 2. So this is how the networking in Docker is very useful. So to communicate between one container to the another containers, by default, there is a common network that is called as Docker 0, using which you can talk from one container to the another container, right? Whereas if you want to even segregate, or if you want to even create a networking isolation, you can achieve it by using the virtual bridge networks or the custom bridge networks that you can create. Now let me explain you this practically. Okay, so theory we have learned. Now let's try practically so that everybody who is watching our video can also understand this practically. So let me share my another screen and explain you. So I hope you are watching the screen. Let me increase the font. So I'm using the same repository. If you people don't have this GitHub repository that I'm using, you can clone the GitHub repository. So if I do git remote -v, people who are already watching our videos, they already know that I am Veeramalla is my GitHub repository, and I have GitHub account, and I have all the demos here inside this I am Veeramalla. So Docker 0 to Hero is basically covering all our Docker examples. So in this case, I'll show you a classic example where I have, let's say, a basic Nginx container. Okay. So what I'll do is I'll just use this Docker run. Okay. -d command where I'm running this Nginx in a detached mode. Let's say this is my login container. Okay. So I'm calling this as, okay, instead of container 1, let me call this as login. Right. So as soon as I do this, what happens? My container is running in the detached mode. Now I can log into this container, right? So I can just say docker exec -it followed by the name of the container, that is login. Let me just say /bin bash. Okay, now I logged into this container. Let me install a few basic things here. Apt update. Let me do update. So once I do the update, I'll install ping command. Okay, by default, ping is not available. So let me install ping. I think the command to install ping is apt-get install iputils, I guess. Let's see. Okay. This is not the command. Let's try to understand. Let's try to take some help here. Mm, Ping. Let's see what is the command for this. Okay, it's iputils ping. No worries. Okay. So as I install this, now you'll see that the ping is installed. Ping minus v. Perfect. So the ping command is installed. Iputils is the package that offers this ping. So now ping is installed. Now let me run another container. Okay. So I'll use the same command, but this time what I'll do is I'll just change the name to logout. Okay. So as I do this, what happens is one more container gets run. Now I can log into this container docker exec minus it again. Or let me first understand the IP address of this container. Okay, so Docker PS, I'll see that there are two containers running. One is the logout container and one is the login container, right? This is login container and this is the logout container. So for login container, I have already logged in here. Let me see what is the IP address. So how do I do that? Docker inspect followed by the name of the container. So as I do this, you'll see that the IP address for this is 172.17.0.2. Let's see what is the IP address for logout. So because we are using the default bridge network, both of them should be in the same subnet. So they are in the same subnet, right? 172.17.0.3 and the other one was 172.0.2. Let me log into this container, which I already logged in, sorry. So I'm already in the login container. Let me do ping 172.17.0.3, which is the IP address of the logout container. Let me see if one container can access the another container which are on the same host. They can definitely do that because they are using the default out of the box bridge networking, which allows one container to talk to the another container, right? So we saw that using the inspect as well. So see here, what does it say? The networking that is available on this container is bridge network because this is a default network, right? So if you want to list out all the networks on this host, what do? You can simply do docker network ls. So as I do this, you will see that, okay, so there is bridge network out of the box, host network, none, and test. Test is one bridge network that I've created. If you want to just delete, you can say docker network rm test. Okay, so the test network is deleted. So again, if I do docker network ls, you will see that there are three out of the box networks. Perfect. Now I told you how to connect from one container to the another container. Also, I told you how to create a networking isolation from one container to another container. Now, this container, login container, was able to talk to the logout container. But now I want to create a finance container, and this container has to be logically isolated from login container. So for that, what I should do, I need to create a bridge network for this finance container, right? So firstly, the command to do that is docker network bridge secure network. Let me call this as secure network. Okay. So what was, okay, sorry. Docker network create, instead of create, I said bridge. Okay. So by default, if I say Docker network create, the default network, custom network that would be created is the bridge network. Okay. So Docker network create secure network. So now if I do Docker network ls, you will see that for any new container that you are creating, either you can attach bridge network out of the box one, either you can attach the host network, or you can also attach the secure network, which is again a bridge network, but it is a custom bridge network that you have created. And the name that we have chosen is secure network. Now, let me try to assign this secure network to the finance container and let us see if this login container can talk to the finance network or not. And my expectation would be they should not be able to communicate with each other because I want to keep this container secure. No other container should talk to it because it has very sensitive information. Let's see how to do it. So let us use the same command called docker run minus D, and here I will name it as finance. But the only thing that I would do is whenever I'm creating this, I will pass an argument called hyphen hyphen network, secure hyphen network. Okay. Sorry, I think the name here, I mean, the syntax here should be is equals to, I guess. Where I am doing wrong. Oh, sorry. Hyphen hyphen name is finance, followed by the networking that I wants to pass and the name of the image, right? So this image is created now, or this container is running in the background. Let me do Docker PS. So you will see login, logout as well as finance. Let's inspect finance and see what is the networking of it. Docker inspect name of the container. So you will notice that here inside the networks previously whenever I was showing you for the login container, it says as bridge, but here it is saying as secure network because we have allocated it a dynamic or the network that we have created. And even if you look at the IP address, it is 172.19. Previously, if we inspect the login container again, so that you can understand the difference parallelly, Docker run logout, you will see that here it would be bridge and here it will not be 172.19 but it would be something else. So let us see if I am right or not. Docker inspect logout. So the network is bridge and the IP address is 172.17. Whereas in this case, the network is 172.19, right? So if you don't, I mean, if you want to see this practically, what you will do, copy this IP address of finance, try to ping it from the login container and you will see that you will not able to reach the finance container. So this is how you will make your container secure using the concept of networking, right? Is this clear? The concept of networking is easy, right? So the login container, if I go back here, there are three containers. Okay. So if I do Docker PS, you have login container, you have logout container, and you have finance container. So login and logout by default are with the bridge network. The out of the box are the default bridge network, so they were able to communicate with each other. Whereas the finance container, right? So it is with the secure network that we have created, so it is completely isolated. Now let me also show you the other case where I want to create a container, but this time I want to create it with the host network. So let's call this as login is done, logout is done. Let's call this as demo. Okay, host demo. So the name of the container is host demo. Docker run minus d hyphen hyphen name host demo. To attach it with the network, what we need to do, we have to pass hyphen hyphen network is equals to host. Okay, so now I'll run a container with the host network and let's see what happens. So what would be the IP address of this host network or the container host demo? Any guesses? Put me the timestamp in the comment section and answer your question. Let's see how many people understood this concept. So if you have got this answer correct, what you will see is the container host demo will have IP address completely different from other containers that we have created till now, the login, logout, and finance, because the networking is the host networking. Let us do Docker PS and you will see that there is a container called host demo. If I inspect this using Docker inspect host demo, you will see that the networking is host and the IP address. You see what is the IP address? There is no custom IP address here because it is binded with the host networking itself. So Docker did not create any virtual network in this case because directly you are able to access this container using the host itself, the host IP address itself. Got it? Is the concept clear? Perfect. So now I hope everybody is understanding what we discussed with the networking. If you have any questions till the point that we have discussed, because in tomorrow's class, what I'll do is I'll talk about few Docker interview questions because everybody have been asking about it. If not, my actual plan was to start with Kubernetes where I wanted to end Docker with networking and start Kubernetes so that people will correlate. Like you will understand the problems with the Docker here. In this case, I have to create my custom networks every time, whenever I want to keep it secure, or even to access these applications inside the container from external world, you have to do some kind of things, right? You have to do some port mappings, you have to do all of these things. So how Kubernetes as a platform or how Kubernetes as a container orchestration solution solves all of these problems, or what happens if a container goes down? What happens if a container you want to scale up because of some load? So Kubernetes has answers to all of these questions: auto healing, auto scaling, uh, all of the classic problems like networking in the container. So my initial intention was end with Docker network, the concept of Docker, and start with Kubernetes. But now, because people are asking about interview questions as well, I will introduce one more class for Docker interview questions. Perfect. So I hope you like the video. If you like the video, click on the like button. If you have any feedback or questions to me, put that in the comment section. And finally, please don't forget to share this video with your friends as well as your colleagues, because it is very important for everyone who are trying to pursue their DevOps career, understand from zero to hero. Like we have already covered 28 classes, so it will be very helpful for them. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.
Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 27 of our complete DevOps journey, and in this class we will talk about Docker bind mounts and volumes. So this is the place where most of the people get disconnected with Docker, right? Whenever they try to understand the bind mounts and volumes, this is where people feel that, oh, Docker is complicated and kind of things go out of their head. But I'll try to make it as simple as possible so that you understand the practical problem and reason why the bind mounts and volumes are implemented. So firstly, what is one of the major problem with a container? Okay, let's say you have a container. Okay, for example, let's understand that we have installed an Nginx application inside this container. Okay, now what this Nginx application does is it continuously you know uh, puts the user information, kind of who is the logged in user, okay, and from which IP address this logged in user has accessed the application. All of this information Nginx tries to store in a log file, right? Now this log file is very important, like because whether you are doing your security auditing of your company, or whether you are performing any kind of details to understand the user information, the log file has to have all the information, like for example of last 10 days, depending upon your organization requirement, or from last 5 days or last 1 week, time to time you perform auditing. For instance, this container has gone down. Okay. So what happens in this case is, because the container has gone down, the log file gets deleted. Why? Because containers are ephemeral in nature. What is the meaning of ephemeral? They are very short-lived, right? If you go to our previous classes, I try to explain you that container does not have a file system by default, right? Because containers are very lightweight in nature. What they usually do is they use all of these resources like CPU, memory, okay, and the storage or the file system, all of these things directly from the kernel or the host operating system, right? You remember, that is why a container is very lightweight in nature. That's what I kept on telling you. Now the problem is, if the container goes down, okay, so it used all of these resources from the host operating system, but they are not a permanent resources for this container. That means if the container goes down, they free up the resources from the operating system and they get killed. So now the user details or the log file of the Nginx is deleted. If the log file is deleted, now organization does not have information of the users who authenticated with that specific organization, or the user IP addresses, or the any kind of information that they want to track or perform auditing on the users is completely deleted. This is problem one. There can be another problem, like let me clear up the screen and explain you. So for example, there can be one more problem where users, where should I this clear up the screen? Just a second. Okay. So there can be a problem, another one, like for example, this is the container. Okay. And this is another container. Let's assume that this is a front end container. Okay. What is this one? This is a front end container. And let's say there is another container called back end container. Now the back end container keeps on writing a file, for example, and this file has to be read by the front end container to display the content. This is a very common use case, right? So it can, like the backend can continuously write a JSON file, or backend can continuously write a YAML file. This can be any application. Even you can consider as a Flipkart or any other application. Okay. So one of the primary purpose of the backend is to serve the users and write some kind of JSON file or XML file, YAML file, or even in some cases, a backend can create HTML file dynamically on its own, and this dynamic content can be served by the front end. So this is a very practical use case. Now, let's assume the same example where the backend container has gone down. Okay, so all the while what backend has done is it kept on writing a HTML file. For example, it wrote half of the HTML file. Okay, or for example, it even like it can serve the HTML files, and it can keep the HTML files in folders where it can say that, okay, this is yesterday's HTML file, this is today's HTML file, or this is 10 days ago HTML file. Now what user can do is, depending upon the user has a section where he can access today's HTML file, yesterday's, day before yesterday's. Okay, so he can access records. But now the problem is, because backend has gone down, and you did not use any persistent file storage. Or what do I mean by persistent? You did not have the permanent backend storage. So the problem with that is, now the entire information is gone. So if the information is gone, now backend, or sorry, the front end can only serve today's HTML page or today's records. Now whenever it tries to read records from yesterday, day before yesterday, or even previous days, the front end will clearly says that no, I don't have the information because backend just gave me records for today. So this is a very classic problem. And this problem, if user is facing this problem, then that means that your application is going completely wrong. And one more example can be, this is a final example that I'm going to explain you. This example can be, like, let's assume there is only one application, okay, and the whole purpose of this application is to read some file. Okay, this file is not on your container. Okay, this is a container. Now what this container does is, it reads a file, okay, that is provided from a cron job on the host. Okay, so or this cron job can be any place, anywhere else, but the entire thing that I wanted to explain is, there is a cron job. What is a cron job? Cron job is a periodical job which is running on the host or somewhere else, and it creates a file on the host. Now again, this file can be a JSON file, XML file, YAML file, or any file that you want to assume. But end of the day, there is a file on the host file system that container wants to read, and it wants to display to the user. How do you do that? If there is no way a container can access your file system, okay, like I told you, what container can do, it can access a it can access CPU, it can access RAM, and it can also take resources from the host operating system. But there is no standard way till now that we learned. The container can take a specific directory or a specific folder from the host operating system, right? So these are the three problems that I explained you. Problem number one, problem number two, and problem number three. In problem number one, the problem was, a container did not, like if you go back, a container did not have a way to actually write details, or we took the example of Nginx, and we tried to understood that if the Nginx file system cannot keep records of previous logs, or whenever somebody comes for auditing, then they will not have access to the previous logs. That means to say that your organization will have to compromise on the details. This is problem number one. Problem number two is, there is a classic front end and back end, and these two try to share information from each other. But because the back end has gone down, or for some reason the problem persists, right? And the problem number three is your app is trying to read some files from the host operating system, but again, it does not know how to read that information. So to solve this classic problem, what Docker has done is Docker has come up with a concept. It has come up with two concepts. Okay, so it allows users to use one of these options. One is, as a user, you can use a concept called bind mounts. Okay, so what is this called? Bind mounts. I hope the things are clear till now. If there is any question that people have, please provide me the timestamp so that I can explain you in the comment section what did you fail to understand. Okay, so there are two options. One is bind mounts and one is volumes. What is bind mounts and what is volumes? So till now the concept is very clear. You understood the problem statement. If you have understood the problem statement, going ahead, it is very easy to understand the solution as well. Okay, so Docker offers you two solutions. One is a very very simple and easy solution. What bind mounts does is it allows you to bind. The name itself tells you it allows you to bind a directory inside your container. Let's say this is your container and this is your operating system. I mean, this is your host. Okay, so for example, this is your host and this is your container. Let's say C1. Now, what bind mounts does is it will bind a folder on your container with a folder on the host. So let's say you have a folder called slash app. So here also you have a folder called slash app, or it can be different names as well. So basically using bind mounts, you can bind them. That means to say any file that you are writing inside let's say this container wants to read some information, so any file that is present on the slash app folder can be always read by the container C1. Or let's say this wants to write some information here, so any file that is available on the specific container the container is writing inside itself will be allowed to access using the directory itself. So even if the container goes down, for example, so what happens is the slash app folder is already available on the host. So whenever next time a new container comes up, let's say a container came up with name C2, or you created a new container with C2, what it can do is again you can bind that specific container with the same slash app folder on the host, so that the information is not lost. So whenever the container has come up, it already has the information. Or for some reason, let's say that the containers are not even coming up, but you still have the user information or whatever details that you want in the slash app folder, right? You understood what I'm trying to explain, right? Perfect. So this is the concept of bind mounts. That means you are binding a specific directory on the host to a specific directory on the container. And now the next concept is about volumes. Now, what does volumes do is volumes also kind of do a same solution, but volumes offer you a better life cycle. Okay, what do I mean by life cycle is basically using volumes, using the Docker CLI. What you can do is using Docker commands, you can create something called as a volume. Okay, so volume is again a logical partition that you are creating on your host. So you create something called as a volume, and you can manage the same things, like you can create a volume, you can destroy a volume. Okay, or you can take this volume out of container C1 and later point of time attach it to C2, or at one single point you can attach a same volume to C1 and C2. So what a volume is doing apart from this bind mounts concept is technically both are doing or both are solving the same problem. Even using a volume, what you are doing is kind of you are attaching a specific folder, or you are attaching a specific file system to the container. But the main advantage is using volume, you are not providing the directory details. Like you are not saying slash app folder on the host should be assigned to a specific folder on the container. Instead, you are saying like create a volume. You are asking Docker to create a volume on the host. Okay. Now this volume is basically a logical partition on your host. So if you go to your host and when you perform DH, right? Sorry, DF, what happens is it will provide you all the disks, right? So similarly, when you do volume, Docker will create a logical disk, or it will create a logical volume. Now this volume will be mounted to your container. Okay, so I'll show you practically, don't worry about it. Like this session is going to be both theory and practical so that you will be able to understand the difference between bind mounts and volumes as well. But there is very less difference, and the biggest advantage that you are getting using volumes is you are managing the entire thing using the Docker CLI itself. And basically, this volumes has a life cycle, right? So why I'm saying that volumes has a life cycle is because whenever you are using volumes, the concept of volumes, you are getting the advantage of managing it, like, creating it, destroying it, all of these things. And one more advantage of using volumes is that, let's say this is your container. Okay. If you are trying to bind a directory onto, if you're using a bind mounts and you are trying to bind one specific directory to another directory on the container, on the host, and this is on the container. So you are only restricted to this specific host. Whereas if you are using volumes, you can create a volume on any place, like you can create on the same host, you can create on any external EC2 instance, for example, or you can use any external storage devices like S3 or NFS. Like you are not restricted with the options. So there are bunch of things that you can create with volumes that are using some external sources. So this is a huge advantage, right? Let's say your host does not have enough disk, or for example, your container requires a huge amount of volume. So, and this volume should later point of time be taken as a backup. Okay. So to do all of these things, your host will be with very limited resources. So what volumes offers you is you can also create it on some external storage devices, or on external compute devices, so that later point of time you can easily take their backup. You can again, like, move them from this cloud provider to your local storage, anything, like you can play around with the volumes. And the other advantage, like I told you, is you don't have to like similar to bind mounts, you don't have to play directly with the when the container is running. Instead, you can manage its life cycle using the Docker commands. So by this time we are like kind of acquainted with the Docker commands. So you already know that whenever we are creating a container or something, we use Docker CLI. Similarly, whenever we are creating a volume, you can simply say Docker create volume followed by the volume name, or you can also say Docker ls, I mean volume ls, to list the volumes. So what is happening is you are making it easy using the for the users using the Docker CLI itself. And you clearly understood that it is very safe to take backups in this case, because you can also mount it using some external storage devices. And some other advantages are these volumes are very easy to share from one container to the another container. So these are some advantages that you have. And finally, if you can think of one more thing, these volumes can be of very high performance as well. For example, your personal laptop, or your storage on where you sorry, your host on where you are hosting your container. Let's say this is of not that high performance. This is a very simple host. Okay. So what you can do is, if your container requires a storage that has high IO, that means let's say your storage has to be read intensive, or your storage has to be write intensive. So in such cases, you can create a very high performance storage, and you can mount it as a volume to your container as well. So these are some of the advantages. Now, I hope things are clear till now, right? So after this, what I'm going to explain is we'll move to practical in a couple of minutes, right? So if you have any questions till now, provide me the timestamp and tell me where exactly you did not understand. Now, there is one common problem, or one common misunderstanding across Docker volumes is, if you go to some documentations, what you would see is somebody would do Docker minus v, and they try to pass bunch of arguments for volumes, and in some places you see Docker hyphen hyphen mount. Okay. So people get confused what is the difference between these things. So in both the cases you will do the same thing. Like whenever you are trying to mount a container, mount a volume into the container, you can either use minus v, or you can either use minus minus mount. Okay. So both are same things, there is only syntax difference. And the reason for this syntax difference is, if you are using minus v, okay, what you are doing is you are attaching a volume, and you will pass everything in a same command. Okay, you'll say you will only differentiate the arguments for this specific mount. Like for example, what is your source? Source means what is your uh, directory on the host. Then what is your destination? Then you can provide some other arguments like uh, if it is a temporary storage, or do you want to provide some permissions or whatever you want to provide. So all the options you provide by simply separating using the comma colon. Whereas if you are using hyphen hyphen mount, then this is more verbose option. What do I mean by verbose? Is in this case you elaborate the details. Like instead of saying the what is the directory, here when you are using hyphen hyphen mount, what you will do is you will say, okay, this is my source, this is my destination on the container, then permissions. This is my permissions. So you basically allow users to understand what you are running. So whenever you are passing a command, you provide all the details so that let's say somebody else is trying to understand this command, so they can simply understand, oh okay, so you are trying to mount a specific directory, or you are trying to mount a specific volume, and these are the parameters that you are passing to the mount. So if you are trying to use these things in your organization, better than minus v option, go for a hyphen hyphen mount, because this is a very verbose option and it will allow users to understand it very simply. So this is the concept of Docker volumes. Now let us try to understand this practically, so that you will kind of get a feel or understanding of how simple volumes is. It is not at all complicated. I'll show you live using my um, terminal. So let me stop sharing this one here. Stop share. Done. So I stopped the sharing. Now let me stop sharing, start sharing the terminal. Right. I hope you are seeing the right screen. Now let me put my terminal up. Perfect. So like I told you, we'll start with a specific command to see how you can understand the life cycle of containers. Okay. So if you simply see here, I can simply use a command called docker volume ls. So it will provide me the details of what are the running volumes, right? So it says that I have a volume called Argo CD, I have a volume called demo, and I have some local volumes. Okay, so whenever you try to play with the volumes, always go for volumes instead of bind mounts. Like I told you, there are two options, right? One is I can either you can bind a specific directory on your host with the specific directory to your container, that is using bind mounts, or you can also play around with the volumes. So always go for the second option, that is volumes, because of the advantages that I told you. You can manage the entire life cycle using the volumes. You can put it in an external storage system, all of these things. So do not go with the bind directories or bind mounts unless you have a specific use case, or you have a specific reason why you want to go for it. Now, if I want to create a volume, it is as simple as running a command called docker volume create. Let me tell you that I'll create a volume called Abhishek. Now see, what happened is you have created a volume. Now what do I mean by you created a volume? So when you do this, what happens is there is a logical partition, or there is a logical folder or file system that is created on this specific uh, host, which you cannot see. Okay, so I cannot directly understand that, okay, which file system or where did this volume get created logically on my host. But now what will you understand is when you do docker volume ls, you have a specific partition called Abhishek, and you can dedicate this specific partition, or you can dedicate this specific volume to one container or multiple containers, right? So this is how you create a volume. I hope things are clear till now. If you have any question, please provide me a timestamp and ask your question. Don't forget to provide me a timestamp, because many times people ask a question and kind of I do not understand at which point are you asking this question. Now, there is a use case where you want to try to understand this volume. Let's say that you did not create this volume. Okay, somebody created this volume, and you simply did docker volumes ls. You understood that, okay, there is a volume called Abhishek, but now let me try to understand what is this volume, where is this volume created, okay, or is this on a local file system, or this is an external file system, or probably you have given a task to clear up all the volumes, unused volumes. So to understand this detail, there is a command where you can understand the details of volume, that is docker volume inspect Abhishek. So when you do this, you get the details. Sorry, there is a typo here. So you get the details of this specific volume. Okay. So when I did docker volume inspect Abhishek. Okay. So this is the command. What you are trying to do is you are inspecting the volume, then it gives you all the details. Okay, so it says that this is created at this specific timestamp. So the driver is local. That means to say that I have created it on a local file system, and this is a logical mount point. Okay, so var lib docker volumes Abhishek hyphen data. Okay, and then you have the name. Finally, you have the scope that is local, and you did not use any options. So this is how you inspect a volume. Okay. So whenever you are trying to perform a cleanup task, or whenever you are trying to do any specific action, so this is how you inspect a volume, and then you can perform your cleanup action. Now, let's say you want to delete volumes. Okay. You are given a cleanup task and you want to delete this volume. So if I would, let me just change my terminal so that it will be more interactive for you people, whoever is watching this video. So I just use ZSH for better user experience. Okay. So now what I can do is I can use a simple command called docker volume rm Abhishek. Okay. So as soon as I do this, what happens is it says that there is a volume called Abhishek that got deleted. Okay. So let me see if it is correct or not. Docker volume ls. I should see. Okay, so clearly see that there is no volume called Abhishek. There is only demo, there is only Argo CD, and there are some local volumes. Let me also delete this volume called Argo CD, Docker volume RM Argo CD demo. So you can delete multiple volumes using a same command line option as well. So you don't have to use any shell script, or you don't have to use anything for deleting multiple volumes if you already know the names, and if you can put it in a single command, or if you can put it in a single line, you can delete multiple volumes using a simple command as well, right? So this is how you start with life cycle of volumes. Now let's start the actual thing. Let's say I want to mount a volume onto my uh, container. So for that, firstly, let me create a container. Let's see if I have any Docker images so that I don't have to write. So I'm using Docker images head minus 5 to print first 5 these things. Okay, so I have containers that are running, but looks like all of these containers have an entry point. If it has already an entry point and CMD, it will be difficult for us to understand. So instead, what I'll do is I'll simply write a Docker file here. It will not take much time. So I'll just say from Ubuntu. That's it. Okay. There is nothing inside this container. So I'm just running a Ubuntu simple container for our understanding. Okay. Now Docker build dot. So it should simply create a uh, okay. I understood what is the problem here. So in my case, just give me a moment. Okay, so what I do is I will use the same Docker 0 to hero repository, and you all know that there is a folder inside the repository called first Docker file. So I'll build the same container. Now it will not take much time. I'll simply say Docker build minus T. followed by a tag called volume demo, for example. And now let us pass this Docker file to it. I can simply say dot because I'm in the same folder. Okay. So now this image is getting built. We know that there is a image called volume, Docker volume. So what I'll do here is I will try to mount a volume that we will create into this specific container. Okay. So for that, we need to use the Docker volume create command to create a volume. We will do both of them together. Okay. So let's wait for this command to get passed. It shouldn't take more than 30 seconds. Okay, now the image is built. So I have an image on my local. So now what I'll do is Docker volume create. Again, let me create a volume called Abhishek. Okay, so now the mounting part is very simple. Like I told you, I would always go for an option called uh, Docker run minus D, where I'm running the container in the detach mode, and I would use an option called hyphen hyphen mount. Okay, so the reason why I will use hyphen hyphen mount is because it will give me a verbose option if at all I want to put this in some shell script, or if at all I want to share this command to other members in the team. It is very easy if I use the hyphen hyphen mount. Even if they're new to Docker, they can simply understand that, oh, okay, what Abhishek is trying to do here is he's trying to use a source. The source is the name of the volume, where he said the name of the volume is Abhishek, comma, target is target on the container, where we will use a folder called slash app, right? And followed by the image details. That's it. So that is all what we will provide. And here the image details would be, I think the image that we created is Docker volume, or you can simply use any other image like Nginx also. Okay. So if you don't want to use the image that we have created in the my first demo, you can also use images like Nginx or HTTPD or something. Okay. So you can simply say Nginx colon latest. So it said the image is not found locally because it's not the image that I created. In this case, you can use this way, or you can also use the previous images that we have built in the uh, previous classes, like the simple calculator image or first demo image or whatever you would like to. Now, what is happening is it is not only running the container, but now it is running the container with a mount. Now this container will have a additional mount. I'll show you how to understand that as well. Let's say you are given a container, you can also understand the details of the container, like if a container has a volume, or if the container it is only using the default space that it has. So to understand that, what you will first do is you use a command called docker ps. What will docker ps do? It will provide you a list of running containers. So in this case, this is one of the running containers, only container, because I don't have any other container that is running. Now you can simply say docker inspect. Here we are not inspecting the volume, but we are actually inspecting the container itself. To do that, what you will do is docker inspect followed by the name of the container. Now, once you do this, you will find the entire details of your container. Okay, what is the IP address of your container, right? So if this container has a mount or not, if this container has all the details that you want. And here you will clearly find if I search for mounts. Okay, so it says that this container is with a mount called Abhishek, and this is the source. That means on the file system, this mount is on that specific directory, and on the container, this mount is slash app. Now you did not create this folder, like I explained you the difference between my bind mounts and the volumes. Whenever you are using a volume, you only create a volume, and using the docker create command, and docker itself will create a logical volume for you. That means it will create a directory on the folder, like it can be on the same host system, or it can be on an external host system. And now this is the destination, and you have some details about the mode, like is it a read write, like are you want to use only a read volume, or do you want to use a write volume? All of these details you can pass through commands. Like I told you, it's not difficult. you can directly provide options here. Let's say if you want to provide additional details, you can simply pause one more comma, and if you want to provide the mode, or if you want to say that this is only read only volume, so you can keep adding using the comma. So this is how you make use of the concepts of volumes. And to stop a volume or to start a volume, what you would essentially do is, firstly you would stop the container. This is very important. Okay, so let's say I want to delete the volume. Now if I directly delete the volume, what happens is Docker volume ls. Okay, so it says that there is a volume called Abhishek. Now try to delete this volume directly. Docker volume rm Abhishek. Okay, so what it says, error, because the volume Abhishek is already in use. So this is very important when you are trying to do it in your organization. Firstly, you have to stop the container, you have to delete the container, only then you will be able to delete this volume. Okay, so always if you are given a task to delete the volumes, firstly stop the containers and then you can delete. Now what did we achieve using this class is, we have created volumes and we have mounted the volumes. Now even if the container that we just created goes down, the data of the container in that specific slash app directory is already available on a volume called Abhishek, so that it can be stored, it can be backed up, it can be shared with some other containers, right? So this is a brief I wanted to explain about bind modes and volumes. So the concept is very simple, and if you start playing around with it, you will hardly take, like, 1 hour or 2 hours to understand the concept of volumes and the bind modes. So if you want to understand more details about these volumes, I'll also share the link in the description where you can follow the complete details of Docker mounts as well as Docker bind mounts as well as volumes. I hope you understood the video, and I think that it is very clear to you. If you have any questions, please share that with me in the comment section. And finally, please share the video with your friends and your colleagues. Thank you so much for watching the video. I'll see you in the next video. Take care, everyone.